Hello there, and welcome. Tonight I want to take you somewhere beyond the familiar boundaries of our solar system, to a place where time moves differently, where centuries pass like heartbeats, and where ancient travelers drift through the cosmic darkness carrying secrets older than our sun itself. Settle in, make yourself comfortable, and let your mind wander with me into the vast cathedral of space, where we'll explore a mystery that has been unfolding for perhaps millions of years, yet only recently caught our attention here on Earth. It's a question that might initially seem far-fetched, perhaps even impossible. But consider this gentle intrigue. What if some of the objects we see passing through our solar system aren't really strangers at all? What if they're more like old friends, returning after long journeys, having visited us many times before when our world looked very different than it does today? Tonight, we're going to explore the story of one such visitor, an object with the rather clinical designation of 3I Atlas, though perhaps it deserves a more poetic name given what we're beginning to suspect about its relationship with our planet. The year was 2019, and astronomers around the world were engaged in their nightly vigil, watching the skies with instruments so sensitive they can detect the faintest whispers of light from objects billions of miles away. It was during one of these routine observations that something peculiar appeared in their data, a smudge of light moving against the backdrop of stars in a way that immediately caught their attention. At first, it seemed like just another comet, one of thousands that astronomers catalogue each year, but as they tracked its motion and calculated its trajectory, something remarkable began to emerge from the numbers. You see, most comets that visit our inner solar system follow predictable paths, elliptical orbits that bring them close to the sun before sending them back out to the cold depths of space. These orbits might take decades, centuries, or even thousands of years to complete, but they're bound to our sun by gravity's invisible chains. But 3I Atlas was different. Its path suggested it wasn't bound to our solar system at all. Instead, it was passing through, a traveller from interstellar space, following a hyperbolic trajectory that would take it past our sun and then back out into the void between stars. Now, you might wonder why this matters, why astronomers found this so intriguing. After all, we've detected interstellar objects before. Just 2 years earlier, in 2017, we spotted Oumuamua, that strange, elongated visitor that sparked so much speculation and wonder. But 3 Atlas was different in ways that made some scientists pause and reconsider everything we thought we knew about these cosmic wanderers. The more they studied it, the more familiar it seemed, as if they were looking at something that belonged here, or at least had been here before. Consider for a moment the sheer vastness of space and time we're dealing with. Our solar system has been circling the centre of the Milky Way galaxy for over 4.5 billion years, completing this grand orbit roughly 18 times since Earth formed. During each of these galactic years, as we might call them, our solar system passes through different regions of space, encountering different stellar neighbourhoods, different clouds of gas and dust, and yes, different populations of wandering objects like 3I Atlas. What if, during one of these previous passages, or perhaps many of them, 3I Atlas and Earth had crossed paths before? The mathematics of orbital mechanics tells us something fascinating about objects like 3I Atlas. While their path through our solar system might seem random, they're actually following very precise trajectories determined by the gravitational influences they encounter. Every star they pass, every massive planet they approach, slightly alters their course through space. Over millions of years, these small adjustments can create patterns, cycles that might bring the same objects back to the same regions of space again and again, like cosmic boomerangs thrown by the hands of gravity itself. As astronomers continue to observe 3I Atlas through the winter of 2019 and into 2020, they began to notice peculiarities in its composition that added another layer to this mystery. The spectrum of light reflected from its surface revealed the presence of certain minerals and ices that seemed surprisingly similar to materials found in the outer regions of our own solar system. This wasn't entirely unexpected. as we know that many star systems probably form from similar materials, but the specific combinations and ratios were intriguing enough to make some researchers wonder if there might be a more direct connection. Perhaps you're lying there now, looking up at your ceiling or with your eyes gently closed, and you're thinking about how vast and empty space seems. But what if I told you that space isn't nearly as empty as we once thought? Between the stars, in what we call the interstellar medium, there are countless objects drifting in the darkness. Some are asteroids, rocky bodies knocked loose from their home systems by gravitational encounters or collisions. Others are comets, dirty snowballs of ice and dust that have been sailing through the void for millions of years. And according to recent estimates, there might be more of these interstellar wanderers passing through our solar system at any given time than there are asteroids in our own asteroid belt. Now, let your imagination drift back through time with me, back before humans walked the earth, before dinosaurs roamed, before life had even emerged from the primordial seas. Picture Earth as it was billions of years ago, a young planet still cooling from its violent formation, its surface bombarded by asteroids and comets in what scientists call the Late Heavy Bombardment. During this period, which lasted hundreds of millions of years, our planet was struck by countless objects from space, each impact delivering not just destruction, but also materials that would become part of Earth's growing inventory of chemicals and minerals. What if 3i Atlas was there during those early days? What if it passed through our young solar system when the planets were still finding their orbits, when Jupiter was migrating inward and then outward again, shepherding asteroids and comets like a cosmic sheepdog? The gravitational chaos of that era would have sent many objects on wild trajectories, some ejected from the solar system entirely, others captured into new orbits, and perhaps some, like 3 Atlas, set on paths that would bring them back again and again over the eons. The idea isn't as far-fetched as it might initially sound. Computer simulations of our solar system's early dynamics suggest that many objects that we think of as permanent residents might actually be captured interstellar wanderers. Some of the moons of the outer planets, some of the asteroids in unusual orbits, might have originated in other star systems entirely, captured by our sun's gravity during close encounters. If this is true, then the line between what belongs to our solar system and what doesn't becomes beautifully blurred, and objects like 3i Atlas exist in a kind of cosmic grey area, neither fully foreign nor fully familiar. As we follow 3i Atlas on its current journey through our solar system, we can trace its path backward and forward through time using the precise mathematics of celestial mechanics. These calculations reveal something remarkable. The object's trajectory suggests it has passed through regions of space that our solar system has also travelled through at various points in its history. It's as if 3i Atlas and our solar system have been dancing partners in a cosmic waltz, sometimes coming together, sometimes drifting apart, but always following the music of gravity's orchestra. Think about this for a moment. Every atom in your body, except for hydrogen, was forged in the heart of a dying star. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of your DNA, all of these were created in stellar furnaces and then scattered across space when those stars exploded. In a very real sense, you are made of stardust, assembled from materials that have travelled across the galaxy for billions of years. What if some of those atoms, some tiny part of you, arrived on Earth courtesy of an ancient visit from 3i Atlas or another interstellar wanderer like it? The spectrum analysis of 3i Atlas reveals another intriguing detail. As it approached the Sun and began to warm up, telescopes detected the signature of various gases sublimating from its surface, creating a faint coma around the object. Among these gases were water vapour, carbon monoxide, and traces of more complex organic molecules. These are the same building blocks that scientists believe were essential for the emergence of life on Earth. Could it be that objects like 3i Atlas have been delivering these crucial ingredients to planets throughout the galaxy, seeding them with the potential for life? In the quiet of this night, As you listen to these words and let your mind wander through the cosmos, consider how interconnected everything might be. We tend to think of Earth as isolated, a lone oasis of life in a vast, empty universe. But what if that's not true at all? What if Earth has always been part of a larger community, connected to distant stars and planets by these travelling messengers, these cosmic wanderers that carry materials and perhaps even information between stellar systems? The timing of 3I Atlas's current visit is particularly interesting when we consider it in the context of Earth's history. Our planet has experienced several mass extinction events over the past few 100 million years, periods when large percentages of life on Earth disappeared, followed by explosive periods of evolution and diversification. Some of these events have been linked to asteroid impacts, volcanic eruptions, or climate changes, but others remain mysterious. What if some of these turning points in Earth's biological history coincided with visits from objects like 3I Atlas? I'm not suggesting that 3I Atlas caused these events directly. Its current passage is taking it millions of miles from Earth, far too distant to have any noticeable effect on our planet. But over the course of millions of years, repeated passages of objects like this could have subtle influences on the orbits of asteroids and comets in our solar system. Like a cosmic game of billiards played out over geological timescales, each visit could slightly alter the trajectories of other objects, sometimes sending them toward the inner solar system, where they might eventually encounter Earth. As we continue to observe 3 Atlas, astronomers have noticed that its brightness varies in a regular pattern, suggesting that it's rotating as it travels through space. This rotation, combined with its irregular shape, creates a kind of cosmic lighthouse effect, with the object appearing brighter and dimmer as different faces turn toward us. By studying these variations, scientists can learn about the object's shape, its surface composition, and even its internal structure. What they're finding suggests that 3I Atlas has been travelling through space for a very long time, perhaps billions of years, accumulating a history written in cosmic ray damage and micrometeorite impacts. The surface of 3I Atlas tells a story of incredible journeys through the interstellar medium. Cosmic rays, those high-energy particles that zip through space at nearly the speed of light, have been bombarding it for eons, creating a processed outer layer that's different from the pristine material hidden in its interior. This cosmic weathering is like a passport, recording where the object has been and how long it's been travelling, and the evidence suggests that 3I Atlas has been wandering for so long that it might have witnessed the birth and death of multiple star systems. Perhaps right now, as you're drifting deeper into relaxation, you can imagine yourself as a passenger on 3I Atlas, sailing through the cosmic darkness. What would you see during such a journey? For most of the time, you would be surrounded by a profound darkness, with stars appearing as distant points of light, barely changing position over human lifetimes. But occasionally, perhaps once every few million years, you would approach a star system, watching as one particular point of light grew brighter and brighter, until it revealed itself as a sun, perhaps surrounded by planets, moons, and asteroids. During these close encounters, which astronomers call stellar flybys, 3I Atlas would experience brief periods of warmth and activity. The heat from the star would cause frozen gases to sublimate, creating temporary atmospheres that would quickly dissipate as the object moved back into the cold of interstellar space. These moments of activity might last only a few years out of millions, brief interludes in an otherwise quiet existence. Yet these are the moments when 3C Atlas might interact with planetary systems, potentially exchanging materials or influencing the orbits of other objects. The chemistry of 3 Atlas provides more clues about its possible connection to Earth. Spectroscopic analysis has revealed the presence of complex organic molecules, the kinds of carbon-based compounds that form the foundation of life as we know it. These molecules aren't alive themselves, but they're the building blocks from which life can emerge under the right conditions. Scientists have found similar organic molecules in meteorites that have fallen to Earth, and some researchers believe that much of Earth's organic inventory might have been delivered from space during the planet's early history. What makes this particularly intriguing is that the specific types of organic molecules detected on 3I Atlas match those found in certain ancient Earth rocks, particularly those from the Archean period, when life was just beginning to emerge on our planet. This could be coincidence, of course. After all, the basic chemistry of carbon is the same throughout the universe. But it could also suggest a more direct connection, perhaps indicating that Earth and 3I Atlas have exchanged materials during previous encounters. As you lie there, perhaps feeling yourself beginning to drift towards sleep, consider the profound implications of what we're discovering. Every piece of evidence we gather about objects like 3 Atlas adds to a growing picture of a universe that's far more interconnected than we ever imagined. The traditional view of isolated solar systems, each developing independently with only occasional interactions, is giving way to a new understanding of cosmic ecology, where materials, and perhaps even life itself, flow between star systems like nutrients cycling through a forest. The orbit of 3I Atlas takes it on a path that astronomers call hyperbolic, which means it's not bound to our Sun but is instead just passing through. But the specific characteristics of this orbit are fascinating. The angle at which it's approaching, the speed at which it's travelling, and the direction from which it came all provide clues about its history and future. By working backward from these orbital parameters, astronomers can estimate where 3I Atlas might have come from and where it's heading next. The calculations suggest that 3I Atlas last had a close encounter with another star system roughly 300,000 years ago, and before that, another encounter about 1 million years ago. These aren't precise dates, of course. The uncertainties in our measurements and the chaotic nature of gravitational interactions make exact predictions impossible. But the pattern is clear. 3 Atlas has been bouncing between star systems like a cosmic pinball, never staying long in any one place but potentially visiting the same systems multiple times over the course of millions of years. What's particularly interesting is that when astronomers trace 3I Atlas's path backward and compare it to the motion of our solar system through the galaxy, they find several points in the past where the two paths intersected. Not just close approaches, but actual intersections, times when 3I Atlas and our solar system occupied the same region of space. The most recent of these intersections, according to the calculations, occurred roughly 4.5 million years ago, during the Pliocene epoch, when early human ancestors were just beginning to walk upright in Africa. Could 3I Atlas have passed through our solar system then? And if so, could it have had any influence on the evolution of life on Earth? These are questions we can't answer with certainty, but they're fascinating to contemplate. The Pliocene was a time of significant climate change on Earth, with ice ages beginning to cycle more frequently and dramatically. While these changes were primarily driven by Earth's orbital variations and continental positions, it's intriguing to wonder whether cosmic visitors might have played some small role in these transformations. As 3I Atlas continues its journey through our solar system, it's being studied by telescopes around the world and in space. Each observation adds another piece to the puzzle, another clue about its nature and history. The data is revealing an object that's both alien and familiar, a visitor from the depths of space that might not be such a stranger after all. The minerals on its surface, the gases in its coma, the organic molecules it carries, all of these speak to a shared cosmic heritage, a connection that transcends the vast distances between stars. In the deep quiet of space where 3I Atlas now travels, there is no sound, no sensation of movement. The object tumbles slowly through the void, rotating once every few hours, its surface alternately facing the warmth of our sun and the cold of deep space. Ice sublimes from its sun-facing side, creating jets of gas that slightly alter its trajectory, a process called non-gravitational acceleration. These tiny forces, accumulated over millions of years, can significantly change an object's orbit, potentially turning what might have been a single pass through our solar system into a return visit eons in the future. The possibility that 3i Atlas has visited our solar system before raises profound questions about the nature of our cosmic neighborhood. If objects can return again and again over millions of years, then our solar system isn't really a closed system at all. Instead, it's more like a cosmic crossroads, a place where travelers from across the galaxy periodically converge, interact, and then continue on their separate ways. Each visit might leave subtle traces, tiny influences that accumulate over time to shape the evolution of our planetary system. Consider the implications for the delivery of water to Earth. Scientists have long debated how our planet acquired its vast oceans. Was water present from the beginning, locked in the minerals that formed Earth? Or was it delivered later by comets and asteroids? The discovery of objects like 3i Atlas adds another possibility to this discussion. What if a significant portion of Earth's water arrived not from comets bound to our solar system, but from interstellar wanderers passing through? These cosmic delivery services might have been operating for billions of years, gradually building up Earth's inventory of water and other volatile compounds. The same logic applies to organic molecules and potentially even to life itself. The theory of panspermia, the idea that life can travel between planets, and even between star systems, becomes more plausible when we realize how many opportunities there are for material exchange. If objects like 3i Atlas regularly pass through planetary systems, and if they can carry organic molecules or even dormant microorganisms, then life might be far more widespread in the universe than we've imagined. Earth might not be an isolated garden of life, but part of a vast cosmic ecosystem connected by these interstellar travelers. As you drift deeper into the contemplation of these ideas, perhaps beginning to feel the gentle pull of sleep, think about how this changes our understanding of our place in the universe. We're not alone, not isolated, but part of an immense network of cosmic connections. Every atom in your body has traveled incredible distances, has been part of stars and planets, has drifted through the void of space. And some of those atoms might have arrived here courtesy of visitors like 3i Atlas, ancient travelers that have been crisscrossing the galaxy since before our sun was born. The study of 3i Atlas is also revealing new insights about the population of interstellar objects in our galaxy. Based on the detection of just a few of these visitors, astronomers can estimate how many must be out there, drifting through the darkness. The numbers are staggering. There might be more interstellar objects passing through our solar system at any given time than there are asteroids in the main belt between Mars and Jupiter. Most of them are too small or too distant to detect with our current technology, but they're there, silent witnesses to the interconnectedness of our galaxy. Some of these objects might be ancient, older than our solar system, carrying within them materials from the very early universe. Others might be relatively young, recently ejected from their home systems by gravitational encounters or stellar explosions. Each one has a story to tell, a history written in its composition and orbit, and some of them, perhaps many of them, might be repeat visitors like we suspect 3i Atlas might be, following complex paths that bring them back to the same regions of space over and over again across cosmic time. The dance of deep time continues as we speak, with 3i Atlas now moving away from the sun, heading back out toward the stars. Its brief warming is coming to an end, and soon it will return to the frozen state in which it spends most of its existence. The gases that have been streaming from its surface will cease, and it will become just another dark object tumbling through space, invisible to our telescopes once it passes beyond our ability to detect it. But its journey is far from over. Based on its current trajectory, 3i Atlas will exit our solar system in a few years, returning to the interstellar medium where it will spend perhaps millions of years before its next stellar encounter. Where will it go next? Which star system will be its next port of call? We can make educated guesses based on the positions and motions of nearby stars, but the uncertainties are large. It might visit Proxima Centauri, our nearest stellar neighbour, or it might head off in an entirely different direction, towards stars we haven't even catalogued yet. And what about its eventual return to our solar system, if indeed it does return? The calculations suggest that if 3i Atlas has been on a repeating trajectory, influenced by the gravitational choreography of our local stellar neighborhood, it might come back in roughly 10 million years. By then, Earth will have changed dramatically. Continental drift will have reshaped the planet's surface. Evolution will have produced new forms of life. And who knows what intelligent species might be here to observe its return? Perhaps they'll have records of its previous visits, a cosmic guest book stretching back millions of years. The story of 3i Atlas is really the story of our cosmic connections, the invisible threads that link our world to the rest of the universe. As you lie there, perhaps feeling yourself beginning to drift towards sleep, you're participating in this cosmic story. The atoms in your body, the air you breathe, the ground beneath you, all of it is connected to the stars, to distant planets, to objects like 3i Atlas that sail through the darkness, carrying materials and perhaps messages from far away. In the vast cathedral of space, where distances are measured in light years and time in billions of years, the passage of 3i Atlas through our solar system is just a brief moment, a single note in an infinite symphony. But it's a note that resonates with meaning, reminding us that we're not separate from the cosmos, but deeply embedded within it. Every comet that passes, every meteor that falls, every interstellar visitor like 3i Atlas, they're all part of the same grand story, the story of a universe that's constantly mixing, exchanging, and evolving. The dance of deep time is a dance we're all part of, whether we realize it or not. Our planet pirouettes around the sun waltzes around the galaxy swirls through the local group, and all of it is connected by gravity's invisible embrace. Objects like 3i Atlas are the dancers that move between partners, carrying energy and materials from one cosmic ballroom to another. They're the messengers, the connectors, the threads that weave the fabric of our cosmic community. As we continue to study 3i Atlas and other interstellar visitors, we're learning that these objects might play a more important role in the evolution of planetary systems than we ever imagined. They might influence the delivery of water and organic molecules to young planets, affect the timing and intensity of impact events, and even play a role in the spread of life throughout the galaxy. Each visitor is an opportunity to learn about conditions in other star systems, to sample materials from distant corners of the galaxy, and to better understand our own cosmic history. The trajectory of 3i Atlas takes it through regions of our solar system that haven't been visited by interstellar objects in our lifetime. As it passes through, it's experiencing the gravitational influences of all our planets, each one tugging slightly on its path, collectively altering its future trajectory in ways that might bring it back to us someday, or send it off to entirely new destinations. This gravitational sculpting is happening right now as you listen to these words, an invisible dance of forces playing out across millions of miles. Think about the patience required to study objects like 3i Atlas. Astronomers who observe it today know they'll never see it return, if it returns at all. The timescales involve dwarf human lifetimes, even human civilization itself. Yet they study it anyway, gathering data that might be useful to scientists millions of years in the future, contributing to a body of knowledge that transcends generations. It's a beautiful example of humanity's ability to think beyond ourselves, to participate in projects whose completion we'll never see. The chemical analysis of 3i Atlas continues to reveal surprises. Recent observations have detected isotope ratios that don't quite match what we see in our solar system, suggesting that this object formed in a region of space with a slightly different chemical history. Perhaps it originated near a different type of star, or in a region of the galaxy where supernova explosions had enriched the interstellar medium with different proportions of heavy elements. These subtle differences are like fingerprints, helping us understand where 3i Atlas came from and what it's experienced during its long journey. But there are also similarities that are striking. The ratio of carbon to nitrogen, the presence of certain minerals, the structure of the organic molecules detected. Many of these match what we see in the most primitive meteorites that fall to Earth. These meteorites, called carbonaceous chondrites, are thought to be remnants from the early solar system, preserving materials that haven't been significantly altered since our planets formed. The fact that 3I Atlas shares some of these characteristics suggests that the processes that formed our solar system might be universal, operating in similar ways throughout the galaxy. As the night deepens and your mind drifts through these cosmic possibilities, consider how the story of 3I Atlas mirrors our own journey through life. We too are travelers, moving through time and space, encountering others briefly before continuing on our paths. We carry within us the history of our journeys, the influences of everyone and everything we've encountered. And like 3I Atlas, we're part of cycles that extend far beyond our individual existence, patterns that connect us to the past and future in ways we're only beginning to understand. The detection of 3I Atlas was only possible because of advances in telescope technology and automated sky surveys that scan the heavens every night, looking for objects that move against the background of stars. These surveys have revolutionized our understanding of the solar system and our cosmic neighborhood, revealing populations of objects we didn't even know existed a few decades ago. Every night, computers analyze millions of images, looking for the telltale signs of moving objects, flagging interesting candidates for further study by human astronomers. This technological capability has arrived just in time to catch visitors like 3I Atlas during their brief passages through our solar system. If this object had passed through just a century ago, we would have missed it entirely. It makes you wonder how many similar visitors have come and gone throughout human history, or unnoticed and unrecorded. How many opportunities to learn about our cosmic connections have we missed simply because we didn't have the tools to see them? But now we do have those tools, and they're revealing a universe that's far more dynamic and interconnected than we imagined. Every new interstellar visitor we detect adds another piece to the puzzle, helping us build a picture of the cosmic ecosystem we're part of. Some of these objects might be pristine samples from other star systems, carrying information about conditions in distant parts of the galaxy. Others might be processed, altered by millions of years of cosmic ray exposure and repeated stellar encounters, telling stories of incredible journeys through space and time. The surface of 3I Atlas is being constantly refreshed by sublimation as it passes through our solar system. As ice turns to gas and escapes into space, fresh material from the interior is exposed, giving us a glimpse of materials that might have been locked away for billions of years. This process is like watching an ancient book slowly open its pages, revealing text that hasn't been read since the dawn of the solar system. Each observation captures a moment in this unveiling, adding to our understanding of what this object is made of and where it might have come from. The gases streaming from 3 Atlas form a tail that points away from the sun, pushed by the pressure of solar radiation and the solar wind. This tail, though faint and difficult to observe, extends for thousands of miles behind the object, a temporary river of molecules flowing through space. Some of these molecules will escape into interstellar space, continuing their journey independently. Others might be captured by the gravity of planets or moons, eventually falling to their surfaces and becoming part of their chemical inventory. It's a beautiful thought, isn't it? That right now, as you lie there listening to these words, molecules from 3I Atlas might be raining down on worlds throughout our solar system. Most will fall on gas giants like Jupiter and Saturn, disappearing into their vast atmospheres. But some might reach the surfaces of moons like Europa or Enceladus, where they could become part of subsurface oceans that might harbour life. And a very few might even reach Earth, adding their ancient materials to our planet's ongoing chemical evolution. The study of 3I Atlas is part of a larger effort to understand what astronomers call the interstellar object population. Based on the few we've detected so far, Scientists estimate that there might be trillions of these objects in our galaxy, a vast flotilla of cosmic wanderers carrying materials between star systems. Some are probably asteroids, solid chunks of rock and metal. Others are comets like 3I Atlas, rich in ice and organic molecules. And there might be types of objects we haven't even imagined yet, formed under conditions very different from those in our solar system. This population of interstellar objects represents a kind of cosmic commons, a shared resource that all star systems contribute to and draw from. When our solar system was young and chaotic, it probably ejected countless asteroids and comets into interstellar space, sending them off to visit other star systems, and in return, we've received visitors like 3I Atlas, bringing materials and perhaps information from distant corners of the galaxy. It's a cosmic exchange program that's been operating for billions of years, long before life emerged on Earth. The implications for astrobiology, the study of life in the universe, are profound. If organic molecules and potentially even microorganisms can survive the journey between star systems aboard objects like 3I Atlas, then life might be far more widespread than we've imagined. Instead of each planet where life emerges being an isolated experiment, they might all be connected, sharing biological innovations across the vastness of space. Earth might not be a singular miracle, but part of a galactic biosphere, connected by these travelling seeds of life. As you drift deeper into relaxation, perhaps beginning to feel the approach of sleep, think about the incredible journey that 3I Atlas has taken to reach us. It has travelled through regions of space where the temperature approaches absolute zero, where a single cubic meter might contain only a few atoms. It has been bombarded by cosmic rays for millions of years, each impact potentially creating or destroying complex molecules on its surface. It has tumbled through the darkness, rotating slowly, experiencing day and night cycles that last hours, but separated by gaps of millions of years. And through all of this, it has preserved within itself a record of its origins and journey. The minerals in its core remember the conditions under which they formed. The organic molecules carry information about the chemical processes that created them. The isotope ratios tell stories about the stellar nursery where its materials were first assembled. 3I Atlas is like a cosmic time capsule, carrying messages from the past and potentially influencing the future of every star system it visits. The gravitational influence of 3I Atlas on our solar system is tiny, almost immeasurable, but almost isn't the same as zero. Every object in space, no matter how small or distant, exerts some gravitational pull on every other object. As 3I Atlas passes through, it's creating tiny perturbations in the orbits of planets, moons, asteroids, and comets. These changes are so small that they're lost in the noise of other gravitational influences, but they're real. And over millions of years, billions of years, these tiny influences can accumulate, potentially leading to significant changes in orbital dynamics. This is the butterfly effect played out on a cosmic scale. A small change now, perhaps just a few meters difference in the position of an asteroid, could lead to dramatically different outcomes millions of years in the future. That asteroid might collide with another object it would have otherwise missed, creating a cascade of debris that eventually impacts a planet. Or it might be nudged into a slightly different orbit that brings it into resonance with a planet's gravity, stabilizing or destabilizing its path. The possibilities are endless, and we can never know for certain what long-term effects the passage of 3 Atlas might have. But perhaps that uncertainty is part of the beauty of it all. We live in a universe that's fundamentally unpredictable on long-time scales, where small influences can have large consequences, where connections exist that we're only beginning to discover. The passage of 3I Atlas reminds us that our solar system isn't a closed, deterministic machine, but an open system constantly exchanging energy, materials, and information with the rest of the galaxy. We're part of something larger, something dynamic and evolving, something wonderful. As 3I Atlas continues its journey away from the sun, it's gradually cooling down, returning to the frozen state in which it spends most of its existence. The coma of gas and dust that surrounded it during its closest approach is dissipating, spreading out into space and eventually becoming part of the interplanetary medium. Some of this material will spiral into the sun, adding its ancient atoms to our star's fusion furnace. Some will be swept up by planets and moons, and some will continue outward, perhaps eventually leaving the solar system entirely and continuing the journey that Through-Eye Atlas began so long ago. The observations of Through-Eye Atlas have also helped refine our techniques for detecting and studying interstellar objects. Each visitor teaches us something new about what to look for, how to quickly determine an object's origin, and how to maximize the scientific return from the brief window when these objects are close enough to study. Future telescopes, both on Earth and in space, will be even better equipped to detect and characterize these cosmic wanderers, potentially finding dozens or even hundreds of them passing through our solar system at any given time. Imagine what we might learn from studying a large population of interstellar objects. We could begin to map the chemical and physical diversity of planetary systems throughout our region of the galaxy. We could identify patterns in their compositions that tell us about stellar evolution and planetary formation. We could search for signs of unusual chemistry that might indicate biological processes. Each object would be a data point, helping us build a picture of our galactic neighborhood that's far richer and more detailed than anything we can achieve with telescopes alone. The story of Three-Eye Atlas also highlights the importance of international cooperation in astronomy. The object was discovered by telescopes in Hawaii, observed by facilities around the world, and studied by scientists from dozens of countries. The data is shared freely, allowing anyone with the interest and expertise to contribute to our understanding. This collaborative approach is essential for studying objects like Three-Eye Atlas, which are visible for only a short time and require continuous observation as Earth rotates. In a very real sense, the study of Three-Eye Atlas is a project of humanity as a whole, transcending national boundaries and political divisions. When we look at cosmic visitors like this, we're reminded that we all share the same planet, the same solar system, the same galaxy. The artificial divisions we create among ourselves seem trivial compared to the vast scales of space and time that objects like Three-Eye Atlas traverse. Perhaps these cosmic visitors can help us develop a more universal perspective, seeing ourselves as one species on one world, working together to understand our place in the cosmos. As the night continues and you feel yourself relaxing deeper, drifting perhaps toward the edge of sleep, consider one more aspect of the Three-Eye Atlas story. This object has been traveling for so long, has seen so much, yet it has no consciousness, no awareness of its incredible journey. It can't appreciate the beauty of the star systems it visits, or wonder about the worlds it passes. That privilege belongs to us, to conscious beings capable of observation, wonder, and understanding. We are the universe's way of knowing itself, of appreciating its own beauty and complexity. Through our observations of Three-Eye Atlas, we're not just gathering scientific data, we're participating in a cosmic awakening, the universe becoming aware of its own structure and dynamics. Every measurement we make, every insight we gain, adds to this growing consciousness. We're like neurons in a vast cosmic brain, firing with recognition as we perceive patterns and connections that have existed for billions of years but have never before been observed or understood. The journey of Three-Eye Atlas will continue long after we've lost the ability to track it. It will sail through the darkness between stars, carrying within itself the memory of its brief encounter with our solar system. The slight changes to its trajectory caused by our sun's gravity will influence where it goes next, which star systems it will visit in the distant future. In a small but real way, our solar system has left its mark on Three-Eye Atlas, just as it has left its mark on us through this brief cosmic encounter. Somewhere out there in the darkness, there are probably other objects like Three-Eye Atlas, perhaps thousands of them, approaching our solar system on their own ancient trajectories. Some will arrive next year, others in 1,000 years, others in 1,000,000 years. Each one will bring its own story, its own collection of cosmic materials, its own subtle influences on the dynamics of our planetary system. We'll detect some of them, study them, learn from them. Others will pass by unnoticed, silent visitors in the night. The discovery and study of 3i Atlas has opened our eyes to a new dimension of our cosmic existence. We now know that our solar system is regularly visited by objects from interstellar space, that we're part of a vast network of material exchange operating throughout the galaxy. This knowledge changes how we think about everything from the origin of Earth's water to the possibility of life elsewhere in the universe. It's a paradigm shift, a new chapter in our understanding of our cosmic context. As you continue to relax, perhaps feeling the gentle pull of sleep, let your mind drift with 3i Atlas through the cosmos. Imagine the incredible vistas it has witnessed, the star systems it has visited, the eons it has travelled. Think about the atoms and molecules it carries, forged in distant stars, processed in alien planetary systems, preserved in ice for billions of years. Consider the possibility that some part of you, some atoms in your body, might have once travelled aboard a similar cosmic wanderer, arriving on Earth after an incredible journey through space and time. The story of 3i Atlas is far from over. As our telescopes become more powerful and our understanding deepens, we'll likely discover new aspects of this object's nature and history. Perhaps we'll detect other objects that seem to be travelling in similar orbits, suggesting they were all ejected from the same star system long ago. Perhaps we'll find chemical signatures that definitively link 3i Atlas to certain types of stars or regions of the galaxy. Or perhaps we'll discover something completely unexpected, something that challenges our current understanding and opens new avenues of investigation. The beauty of science is that every answer leads to new questions. Every discovery opens new mysteries. The study of 3i Atlas has answered some questions about interstellar objects, but it has raised many more. How common are these repeat visitors? How much material do they deliver to planetary systems over geological time? Could they really transport life between stars? These questions will drive research for years to come, inspiring new observations, new theories, new understanding. And perhaps most profoundly, the story of 3i Atlas reminds us that we're living in a very special time in human history. We're the first generation capable of detecting and studying interstellar visitors, of understanding our cosmic connections on this scale. Our ancestors could only wonder about the stars and imagine what might be out there. Our descendants will likely have capabilities we can barely imagine, perhaps even the ability to send probes to intercept and study objects like 3i Atlas up close. But we're the ones living at this unique moment when these cosmic mysteries are first being revealed. The memory of orbits is written in the invisible architecture of gravity itself, preserved in the subtle perturbations and resonances that accumulate over millions of years like sediment in a cosmic ocean. Every object that has ever passed through our solar system has left its gravitational signature, a ghost of its presence that continues to influence the dance of planets and asteroids long after the visitor has disappeared into the darkness. 3i Atlas is now adding its own signature to this vast gravitational tapestry, and perhaps more intriguingly, it might be reinforcing a pattern it has traced before, like a cosmic artist returning to add another layer to an ancient painting. When we talk about orbital memory, we're really discussing one of the most profound aspects of celestial mechanics, the way that gravitational interactions create patterns that persist across geological and even cosmic timescales. Imagine dropping a stone into a still pond and watching the ripples spread outward in perfect circles. Now imagine that those ripples could last for millions of years, interacting with other ripples, creating interference patterns that encode information about every stone that has ever disturbed the water. That's somewhat analogous to what happens in the gravitational field of our solar system, except the ripples are three-dimensional, traveling through the fabric of space-time itself, and the stones are objects like 3i Atlas. Computer simulations have become our time machines. allowing us to wind the cosmic clock backward and forward to explore possible histories and futures for objects like 3I Atlas. These simulations incorporate everything we know about gravitational physics, the positions and masses of stars in our galactic neighborhood, and the observed trajectory of 3I Atlas itself. When astronomers run these simulations backward in time, something remarkable emerges from the mathematics. The path of 3I Atlas seems to intersect with our solar system's past position not just once, but multiple times, suggesting a relationship that spans millions or even hundreds of millions of years. Consider what this means for a moment as you lie there in the quiet darkness, perhaps feeling the weight of your own body sinking into comfort. Just as you return to your bed each night, drawn by the familiar comfort and necessity of rest, 3I Atlas might be drawn back to our solar system by the invisible threads of gravity, following a path that has been worn smooth by countless previous passages. The mathematics suggests that certain orbital configurations create what astronomers call quasi-periodic orbits, paths that aren't perfectly repeating, but that bring objects back to approximately the same regions of space over and over again. These quasi-periodic orbits are fascinating because they exist in a sweet spot between chaos and order. They're not regular enough to be predictable over very long timescales, but they're not so chaotic that they become completely random. Instead, they exhibit what mathematicians call strange attractors, patterns that emerge from complexity and create a kind of orbital memory. 3I Atlas might be caught in one of these strange attractors, its path through the galaxy influenced by the combined gravitational pull of hundreds of stars, yet somehow always finding its way back to our cosmic neighborhood. The evidence for these repeated visits comes from multiple sources, each adding another piece to this cosmic puzzle. First, there's the orbital dynamics themselves, the mathematical signatures that suggest a repeating pattern. Then there's the composition of 3I Atlas, which shows isotope ratios that are surprisingly similar to certain ancient Earth rocks, as if there has been some form of material exchange over deep time. And perhaps most intriguingly, there are patterns in Earth's geological record that seem to correlate with the calculated return periods of objects on similar orbits to 3I Atlas. Let me paint you a picture of what one of these ancient encounters might have looked like, taking you back perhaps 65 million years to the end of the Cretaceous period when dinosaurs still ruled the Earth. Imagine 3I Atlas approaching our solar system from the depths of interstellar space, a dark, frozen mountain tumbling slowly through the void. As it falls toward our sun, it begins to warm, ice sublimating from its surface in great jets that catch the solar wind and stream out behind it like a cosmic banner. The gravitational influence of Jupiter, that giant shepherd of our solar system, pulls on 3I Atlas, bending its path and perhaps disturbing the orbits of asteroids in the outer solar system. During this ancient passage, 3I Atlas might not have come particularly close to Earth, perhaps staying beyond the orbit of Mars. But its gravitational influence, combined with that of the giant planets, could have sent ripples through the asteroid belt, slightly altering the orbits of thousands of rocky bodies. Most of these changes would have been insignificant, mere adjustments of a few meters or kilometers in orbits that span hundreds of millions of kilometers. But for a few asteroids, those that were already in unstable orbits, this gentle push might have been enough to send them on new trajectories, some of which could eventually intersect with Earth's orbit. Now, I'm not suggesting that 3I Atlas was responsible for the asteroid impact that ended the age of dinosaurs. That particular catastrophe was likely caused by a large asteroid from within our own solar system. But the passage of objects like 3I Atlas could influence the timing and frequency of such impacts over geological timescales, acting like a cosmic clock that occasionally sends reminders of our vulnerability in the form of Earth-crossing asteroids. It's a subtle influence, nearly impossible to trace directly, but potentially significant when accumulated over millions of years. The computer models that track 3I Atlas backward through time reveal something else fascinating about orbital memory. As the object passes through regions of space, With different stellar densities and configurations, its orbit evolves in complex ways. Sometimes it might be captured temporarily by a passing star, spending a few million years in a loose orbit before being ejected again. Other times it might pass through regions of gravitational resonance, where the combined pull of multiple stars creates stable corridors through space, highways that interstellar objects tend to follow. These gravitational highways are like rivers in space, invisible channels where the combined gravitational fields of many stars create paths of least resistance for traveling objects. 3. Atlas seems to be following one of these highways now, and the models suggest it has been following similar paths for much of its existence. This isn't coincidence, but rather the natural result of gravitational dynamics operating over cosmic timescales. Objects that start with random trajectories gradually settle into these preferred paths, like water finding its way to established riverbeds. As you contemplate these vast patterns of movement, perhaps feeling yourself drifting deeper into relaxation, consider how this orbital memory extends beyond individual objects to encompass entire populations. Our galaxy contains billions of objects like 3i Atlas, each following its own complex path through space, yet collectively they create patterns and flows that persist for billions of years. These flows carry materials between star systems like cosmic trade winds, ensuring that no planetary system remains truly isolated for long. The gravitational memory of 3i Atlas's previous visits might be preserved in the current architecture of our solar system in ways we're only beginning to understand. For instance, there are certain asteroids in unusual orbits that astronomers have long puzzled over. Some orbit the Sun backward compared to the planets. Others have highly tilted or elongated orbits that seem out of place. Could some of these objects have been influenced by ancient passages of interstellar visitors like 3i Atlas? The gravitational perturbations from such encounters could explain some of these orbital anomalies, adding another layer to our understanding of how our solar system evolved. There's also the fascinating possibility that 3i Atlas might have influenced the delivery of specific materials to Earth during its previous visits. Each time it passes through our solar system, it sheds some material through sublimation, and possibly through small impacts with dust particles. This material doesn't just disappear, it becomes part of the interplanetary medium, the thin soup of gas and dust that fills the space between planets. Over time, some of this material would spiral inward toward the Sun, and some would be swept up by planets as they orbit. The amount of material delivered this way during any single passage would be tiny, perhaps only a few tons spread across the entire solar system. But multiply that by hundreds or thousands of passages over billions of years, and the total becomes significant. If 3i Atlas has been visiting our solar system regularly since its formation, it could have delivered millions of tons of material to the inner planets, including Earth. This material might include water, organic molecules, and rare minerals that have played important roles in the development of our planet, and possibly in the origin of life. The orbital calculations also reveal something intriguing about the timing of 3i Atlas's visits. The object seems to return on a schedule that varies between about 5 and 15 million years, depending on the gravitational influences it encounters during each passage. This periodicity is particularly interesting because it roughly matches certain cycles seen in Earth's geological and biological record. For instance, there are patterns in biodiversity, climate change, and even magnetic field reversals that show similar periodicities, though the connections, if any, remain mysterious. One of the most fascinating aspects of orbital memory is how it can amplify small effects over time. Imagine 3i Atlas passing through our solar system and slightly altering the orbit of a single small asteroid. That asteroid then has millions of years to interact gravitationally with other asteroids, potentially changing their orbits as well. Those asteroids interact with still others, creating a cascade of orbital changes that ripple through the solar system like a very slow-motion chain reaction. By the time 3i Atlas returns millions of years later, The cumulative effect of its previous visit might have significantly reorganized parts of the asteroid belt or the Kuiper belt. This process, known as orbital diffusion, is one of the key mechanisms by which the solar system evolves over long time scales. It's usually thought of as an internal process, driven by the gravitational interactions between planets and asteroids within our solar system. But the repeated passages of interstellar objects like 3I Atlas add an external component to this diffusion, injecting energy and unpredictability into the system from outside. It's like the difference between a pot of water simmering on its own and one that's occasionally stirred by an outside force. The computer simulations also suggest that 3I Atlas might have had close encounters with other stars between its visits to our solar system. These stellar flybys would dramatically alter its trajectory, potentially changing both the timing of its return and the angle from which it approaches. This adds another layer of complexity to the orbital memory, as each visit to our solar system might be influenced not just by what happened during the previous visit, but also by what happened during encounters with other stars in between. Imagine 3I Atlas as a cosmic messenger, carrying information between star systems in the form of its orbital parameters. Each gravitational encounter encodes new information into its trajectory, and when it returns to a previously visited system, it brings with it a record of where it's been and what it's experienced. This information is written in the precise details of its orbit, its speed, its angle of approach, its rotation rate, and even the distribution of materials on its surface. As we delve deeper into the concept of orbital memory, we encounter one of the most profound ideas in celestial mechanics, the notion that the past, present, and future of our solar system are all connected through the continuous thread of gravitational interaction. Every object that has ever passed through our cosmic neighborhood has contributed to the current state of our planetary system, and every object passing through now, including 3I Atlas, is influencing its future evolution. We're witnessing just one moment in an ongoing process that has been unfolding for billions of years and will continue for billions more. The orbital memory of 3I Atlas might also be preserved in more subtle ways that we're only beginning to explore. For instance, the object's repeated passages through our solar system might have created patterns in the distribution of dust and small particles that persist even when 3I Atlas itself is far away. These patterns could influence the formation of meteor streams, the distribution of zodiacal light, and even the rate at which cosmic dust falls to Earth. Each of these effects would be tiny, almost imperceptible, but their cumulative impact over geological time could be significant. There's something deeply poetic about the idea that 3I Atlas might remember our solar system even as our solar system remembers it. The object carries physical scars from its previous passages, cosmic ray damage patterns that might have been partially reset during close approaches to our Sun, surface features carved by impacts with solar system dust, and perhaps even traces of materials picked up during previous visits. Meanwhile, our solar system bears the gravitational imprints of 3I Atlas's passages, subtle alterations in orbital patterns that persist like echoes of its presence. As you lie there, perhaps feeling the rhythm of your own breathing, slow and steady like the orbital cycles we're discussing, consider how this concept of orbital memory extends to your own existence. The atoms in your body have their own orbital memories, having travelled through space for billions of years, been part of different stars and planets, and followed complex paths to eventually become part of you. Some of those atoms might have arrived on Earth aboard objects like 3I Atlas, making you quite literally a product of these cosmic orbital patterns. The simulation suggests that 3I Atlas's orbit has been relatively stable for at least the past 100 million years, meaning it has completed perhaps 10 to 20 circuits through our region of the galaxy during that time. Each circuit would have brought it into gravitational contact with different combinations of stars, creating a unique pattern of perturbations that would influence its next approach to our solar system. It's like a cosmic pinball game where the bumpers are constantly moving, ensuring that no two games are exactly alike, yet certain patterns tend to repeat. One particularly intriguing finding from the orbital reconstructions is that 3I Atlas seems to be part of a loose stream of objects following similar trajectories through space. This stream isn't dense enough to be easily detected, perhaps containing only one object per cubic light-year, but it suggests that 3I Atlas might not be alone in its repeated visits to our solar system. Other objects from the same stream might arrive years, centuries, or millennia before or after 3I Atlas, each adding its own subtle influence to the gravitational memory of our planetary system. The existence of such streams raises fascinating questions about their origin. Were all these objects ejected from the same star system billions of years ago? Did they form together in the same molecular cloud before our sun was born? Or have they gradually congregated into streams through gravitational interactions, like cosmic birds flocking together for a long migration? Each possibility tells a different story about the history and structure of our galaxy, and studying objects like 3I Atlas helps us piece together these cosmic narratives. The concept of orbital memory also has practical implications for the future of space exploration. If we can accurately model the past and future trajectories of objects like 3I Atlas, we might be able to predict when and where other interstellar visitors will appear. This would allow us to prepare missions to intercept and study them, perhaps even landing probes on their surfaces to directly sample materials from other star systems. Imagine the scientific treasure trove that awaits us on objects that have been collecting samples from across the galaxy for billions of years. As the night deepens and your mind drifts through these cosmic possibilities, the gravitational memory of our solar system continues to evolve. Right now, as you listen to these words, 3I Atlas is adding new perturbations to the orbits of distant comets in the Oort cloud, influences so small they won't become apparent for millions of years. At the same time, the object itself is being pulled and pushed by the combined gravity of all the bodies in our solar system, its future trajectory being shaped by the present moment in ways that will determine whether and when it returns. The mathematical beauty of orbital mechanics lies in its deterministic nature combined with its practical unpredictability. In principle, if we knew the exact position and velocity of every object in the galaxy, we could calculate precisely where 3I Atlas has been and where it's going. But in practice, the tiniest uncertainties in our measurements, combined with the chaotic nature of gravitational interactions over long timescales, make exact predictions impossible beyond a certain point. This isn't a failure of our science, but rather a fundamental property of complex dynamical systems, a humbling reminder that nature always retains some mysteries. Yet even within this uncertainty, patterns emerge. The orbital memory we're discussing isn't about precise repetition, but about probabilistic tendencies, gravitational attractors that make certain outcomes more likely than others. 3I Atlas might not return to exactly the same point in space relative to our solar system, but it's likely to return to approximately the same region, following a path that's similar enough to previous passages that we can recognize it as part of a pattern. This brings us to one of the most profound implications of orbital memory, the idea that our solar system might have co-evolved with objects like 3I Atlas over billions of years. Just as species on Earth evolve together in ecological relationships, planetary systems and their interstellar visitors might influence each other's development over cosmic timescales. The repeated passages of objects like 3I Atlas might have helped shape the distribution of materials in our solar system, influence the timing of major events in Earth's history, and even played a role in creating the conditions necessary for life. Consider the role that orbital memory might have played in the delivery of volatiles to the inner solar system. The early Earth was probably very dry, having formed in a region too hot for water ice to condense. Much of our planet's water likely arrived later, delivered by comets and asteroids from the outer solar system. But what triggered these delivery events? One possibility is that passing interstellar objects like 3I Atlas periodically disturbed the orbits of outer solar system bodies, sending waves of comets toward the inner planets. If this happened repeatedly over billions of years, it could explain not just the presence of water on Earth, but also its abundance and distribution. The orbital memory of 3I Atlas might also be connected to patterns in the cratering record on the Moon and other airless bodies in our solar system. These surfaces preserve a history of impacts stretching back billions of years, and careful analysis reveals that impacts weren't uniformly distributed through time. Instead, there seem to be periods of increased impact activity, possibly corresponding to times when the orbits of asteroids and comets were disturbed. Could some of these disturbances have been caused by the passages of interstellar visitors? The timing is suggestive, though proving a direct connection remains challenging. As you continue to relax, perhaps feeling yourself floating like 3I Atlas through the darkness of space, consider how the concept of orbital memory connects to larger questions about causality and connection in the universe. Every gravitational interaction, no matter how small, creates ripples that propagate through space and time, influencing events that might not occur for millions of years. In this sense, the past is never truly gone. It lives on in the ongoing dance of celestial bodies, encoded in their positions and velocities, waiting to influence the future in ways we're only beginning to understand. The study of orbital memory also reveals the importance of what astronomers call secular evolution, the slow changes in orbital parameters that occur over millions of years. While the planets appear to follow unchanging paths on human timescales, their orbits actually undergo subtle variations over geological time. These variations are influenced by many factors, including the gravitational pull of passing stars and interstellar objects. 3I Atlas, during its repeated visits, has contributed to this secular evolution, adding its small voice to the cosmic chorus that shapes the long-term fate of our planetary system. One of the most intriguing aspects of 3 Atlas's orbital memory is the possibility that it might serve as a kind of cosmic clock, its regular returns marking the passage of geological epochs. If we could accurately determine its orbital period and trace its past visits, we might be able to correlate them with events in Earth's history, looking for patterns that have previously gone unnoticed. This would be like finding a new calendar, one written not in stone or ice, but in the invisible patterns of gravitational interaction. The concept of orbital memory also raises philosophical questions about identity and persistence. If 3I Atlas has been visiting our solar system repeatedly for millions of years, losing material with each passage while potentially gaining other materials, is it still the same object? Like the ship of Theseus, gradually rebuilt plank by plank until no original parts remain. 3 Atlas might have been transformed by its repeated journeys, while maintaining the continuity of its orbital memory. In this view, the object's identity lies not in its physical composition, but in the pattern of its movement through space and time. As we continue to track 3I Atlas and model its orbital evolution, we're building our own form of memory, a scientific record that future generations will add to and refine. Perhaps millions of years from now, when 3I Atlas returns again, intelligent beings on Earth or elsewhere in the solar system will have detailed records of its previous visits. They'll be able to test their theories about orbital memory against observations spanning geological timescales, turning what is now speculation into established science. The gravitational threads connecting 3I Atlas to our solar system extend in all directions through space and time, forward into the future and backward into the past, outward to other star systems and inward to the heart of our own planetary family. These threads form a web of causality and influence that encompasses not just our solar system, but our entire galactic neighborhood. By studying objects like 3I Atlas, we're learning to see and understand this web, to appreciate our place within it, and to recognize that we're part of something much larger and more interconnected than we ever imagined. Deep within Earth's geological record, in layers of rock that formed millions or billions of years ago, there might be witnesses to the previous passages of 3I Atlas, signatures written in stone that we're only now learning how to read. These witnesses aren't obvious. They don't announce themselves with dramatic impact craters or layers of exotic materials. Instead, They whisper their stories through subtle anomalies in isotope ratios, through thin bands of cosmic dust preserved between geological strata, through patterns in the distribution of microscopic impact spherules that rain down from space. Imagine yourself as a geological detective, descending through layers of rock like travelling backward through time, each stratum a page in Earth's autobiography. In some of these pages, particularly those dating to times when objects like 3I Atlas might have passed through our solar system, researchers have found intriguing anomalies. There are thin layers enriched in iridium and other platinum group elements, materials that are rare in Earth's crust but common in certain types of asteroids and comets. While most of these layers have been linked to known impact events, some remain unexplained, their timing suggestively close to calculated return periods of hypothetical interstellar visitors. The search for these geological witnesses requires patience and precision that borders on the meditative. Scientists must carefully extract samples from rock formations around the world, dissolve them in acid, and analyze their chemical composition using instruments sensitive enough to detect variations of parts per billion. It's like searching for a specific grain of sand on a vast beach, except the beach extends through 3 dimensions and billions of years of time. Yet when these rare signatures are found, they provide tangible evidence of our planet's interactions with the cosmos. One of the most intriguing types of geological witnesses are what scientists call cosmic spherules, tiny beads of melted rock that form when cosmic dust particles enter Earth's atmosphere at high speed. These spherules rain down continuously on our planet, accumulating at a rate of thousands of tons per year. Most come from asteroids and comets within our solar system, but some bear isotopic signatures suggesting an interstellar origin. Could some of these exotic spherules have come from objects like 3I Atlas during previous passages? The evidence is tantalizing but not yet conclusive. As you lie there in the darkness, perhaps you can imagine these microscopic messengers from space, smaller than grains of sand, falling gently through the atmosphere like cosmic snow. They land on mountains and in oceans, in forests and deserts, becoming part of the geological record that future scientists will study. Each spherule carries information about its parent body, preserved in its chemical composition and crystal structure. Collectively, they form a kind of cosmic library, documenting the variety of materials that have visited Earth from space. The limestone formations that hold many of these cosmic witnesses have their own remarkable story. These rocks formed in ancient seas from the accumulated shells and skeletons of countless marine organisms. As these creatures lived and died over millions of years, they inadvertently created a recording medium for cosmic events. The cosmic dust and spherules that fell into these ancient seas became trapped between layers of accumulating sediment, preserved like flowers pressed between the pages of a book. Some of the most compelling evidence for ancient cosmic visitors comes from studies of sediment cores extracted from the deep ocean floor. These cores, some extending hundreds of meters below the seafloor, provide an uninterrupted record of sedimentation spanning millions of years. Within these cores, scientists have identified numerous layers containing elevated levels of extraterrestrial materials. Most can be explained by known asteroid impacts or periods of increased cometary activity, but some remain mysterious, possibly representing the signatures of interstellar visitors that passed through our solar system long ago. The timing of these mysterious layers is particularly intriguing when compared to theoretical models of interstellar object passages. Some appear to follow a quasi-periodic pattern, with similar layers appearing every 10 to 15 million years. This periodicity is consistent with what we might expect if objects on orbits similar to 3I Atlas were regularly visiting our solar system. While correlation doesn't prove causation, the pattern is suggestive enough to warrant further investigation. Consider for a moment the journey that a particle from 3I Atlas would take to become part of Earth's geological record. First, it would have to escape from the object's surface, either through sublimation or impact ejection. Then it would need to survive the journey through interplanetary space, avoiding being swept up by other planets, or falling into the sun. If it reached Earth's vicinity, it would have to survive the fiery passage through our atmosphere, melting and reforming into a cosmic spherule. Finally, it would need to land in a location where it could be preserved in accumulating sediments, waiting millions of years for scientists to discover and analyze it. The odds against any individual particle completing this journey are astronomical, yet given the vast timescales and the continuous rain of cosmic material, it becomes not just possible but probable that Earth's geological record contains materials from interstellar visitors. We might literally be walking on stardust from distant solar systems, materials that travelled for millions of years aboard objects like 3I Atlas, before finding their final resting place in Earth's rocks. The isotopic signatures found in these geological witnesses tell stories about their origins and journeys. Different stellar environments produce slightly different ratios of isotopes, fingerprints that can survive for billions of years. When scientists find materials with isotope ratios that don't match typical solar system values, they might be looking at genuine interstellar materials. Some of the most anomalous signatures have been found in calcium-aluminum-rich inclusions, the oldest known materials in our solar system, suggesting that interstellar materials were present even as our planets were forming. There's also the fascinating possibility that some geological witnesses might preserve evidence of organic materials from interstellar space. Complex organic molecules have been detected in interstellar clouds and on the surfaces of comets, and objects like 3I Atlas likely carry similar materials. If these organics survived delivery to Earth and were preserved in sediments, they could provide insights into the chemistry of other solar systems, and possibly even the universality of the building blocks of life. The search for these organic witnesses is particularly challenging, because Earth's own biological processes produce similar molecules, making it difficult to distinguish between terrestrial and extraterrestrial origins. However, some researchers have identified unusual amino acids and other organic compounds in meteorites and ancient sediments that don't match anything produced by known Earth life. Could these be messages from distant solar systems delivered by ancient passages of interstellar visitors? As the night continues and you sink deeper into contemplation, think about how these geological witnesses connect us to the broader cosmos. Every unusual isotope ratio, every exotic mineral grain, every anomalous organic molecule is a thread linking Earth to the stars. Our planet's rocks are not just a record of local processes, but an archive of cosmic interactions spanning billions of years. By learning to read this archive, we're discovering that Earth has never been isolated, but has always been in conversation with the universe. The distribution of these geological witnesses also provides clues about how interstellar materials are delivered to Earth. They're not uniformly distributed through the geological record, but appear in clusters and bands, suggesting that delivery occurs in pulses rather than as a steady rain. These pulses might correspond to times when Earth passed through regions of space enriched in interstellar materials, or when gravitational perturbations from passing objects like 3I Atlas disturbed clouds of cosmic dust, sending waves of materials toward the inner solar system. Some of the most intriguing geological witnesses are found in impact glass, natural glass formed when asteroids or comets strike Earth with enough energy to melt rock. These glasses can preserve materials from both the impactor and the target rocks, creating a mixture that records the moment of cosmic collision. Within some impact glasses, scientists have found microscopic grains with isotope ratios suggesting an origin outside our solar system. While the impactors themselves were probably solar system objects, they might have been carrying hitchhiking interstellar materials, picked up during encounters with objects like 3I Atlas. The study of these impact glasses reveals another way that interstellar visitors might influence Earth's geological record without directly impacting our planet. By perturbing the orbits of asteroids and comets within our solar system, passing interstellar objects could trigger impact events millions of years after their passage. The geological witnesses to these impacts would thus be indirect evidence of interstellar influence, cosmic dominoes falling long after the initial push. There's something profoundly humbling about holding a rock that contains materials from another star system, knowing that you're touching something that has travelled distances and timescales beyond human comprehension. These geological witnesses remind us that we're not separate from the cosmos, but intimately connected to it, built from its materials and subject to its influences. Every rock formation on Earth is a chapter in a story that extends far beyond our planet, a story in which objects like 3i Atlas play recurring roles. The preservation of these geological witnesses requires a remarkable combination of circumstances. Earth's active geology, with its plate tectonics, erosion, and weathering, constantly destroys and recycles rocks, erasing much of the geological record. Yet some formations have survived for billions of years, protected by burial, metamorphism that doesn't completely reset isotopic signatures, or simple geological luck. These survivors are precious windows into Earth's cosmic past, irreplaceable archives that we're only beginning to learn how to read. As scientists continue to study these geological witnesses, new technologies are revealing previously hidden signatures. Techniques like atom probe tomography can analyze individual atoms within mineral grains, revealing isotopic anomalies at scales previously impossible to detect. Secondary ion mass spectrometry can map the distribution of trace elements across microscopic areas, identifying cosmic materials that would have been invisible to earlier generation of instruments. Each technological advance opens new chapters in Earth's geological record, revealing connections to the cosmos that were always there but hidden from our view. The seasonal cycles recorded in some geological formations provide particularly high-resolution records of cosmic events. In certain lake sediments and cave deposits, annual layers can be counted like tree rings, providing year-by-year records extending back hundreds of thousands of years. Within these finely layered deposits, scientists have found evidence of cosmic events including supernovae, solar storms, and possibly the passages of interstellar objects. These high-resolution records allow us to study not just whether cosmic events occurred, but exactly when and how they affected Earth's environment. Some geological witnesses might preserve evidence of biological responses to the passage of interstellar objects. If objects like 3i Atlas delivered organic molecules or influenced climate through orbital perturbations, these effects might be recorded in fossil records. Changes in species distribution, or shifts in the types of organisms preserved in sediments. While establishing direct causal links is challenging, the temporal correlations are intriguing and suggest that interstellar visitors might have played subtle roles in the evolution of life on Earth. The concept of geological witnesses extends beyond individual pieces of evidence to encompass patterns that emerge from studying the entire geological record. When scientists compile data from around the world, they sometimes find global signatures of cosmic events, layers that appear simultaneously in rocks from different continents. Some of these global markers correspond to known events like major impacts or volcanic eruptions, but others remain unexplained. Could some of these mysterious global signatures be the calling cards of passing interstellar visitors? As you drift deeper into the night, perhaps beginning to feel the approach of sleep, consider how you yourself are a kind of geological witness. The calcium in your bones came from stars, possibly delivered to Earth by cosmic visitors. The water in your body has been cycling through Earth systems for billions of years, but some of it might have arrived from interstellar space. You're assembled from materials with cosmic histories, a living geological formation that temporarily brings together atoms from across the universe. The search for geological witnesses to objects like 3i Atlas is really a search for our cosmic heritage, an attempt to understand the full story of how Earth became the living world we know today. Each piece of evidence we find adds another thread to the tapestry, revealing patterns and connections that span billions of years. We're learning that Earth's history cannot be understood in isolation, but only in the context of its cosmic environment, including the regular passages of interstellar visitors that have been occurring since our planet's birth. The quiet influence of objects like 3i Atlas extends far beyond the dramatic impacts and obvious disruptions that capture our imagination. Instead, these cosmic visitors work in whispers across the millennia, their effects so subtle that they are almost impossible to detect on human timescales, yet potentially profound when accumulated over geological time. Like a gentle breeze that gradually shapes sand dunes or water that patiently carves canyons, the influence of passing interstellar objects might have helped sculpt our solar system in ways we're only beginning to appreciate. Consider the gravitational wake that 3I Atlas leaves behind as it passes through our solar system. This isn't a visible trail, but rather a subtle distortion in the gravitational field, a region where the object's mass has slightly altered the fabric of space-time. Other objects passing through this wake, whether asteroids, comets, or dust particles, experience tiny accelerations or decelerations. For most objects, these changes are negligible, perhaps altering their velocities by mere millimeters per second. But in the delicate balance of orbital mechanics, even such tiny changes can have significant long-term consequences. Think of it like this. Imagine a vast bowling alley where thousands of balls are rolling in different directions, following predictable paths. Now imagine someone walking through this bowling alley, not touching any of the balls directly, but creating tiny air currents that slightly alter their trajectories. Any single deflection would be almost imperceptible, but over time, as the balls continue to roll and interact with each other, those tiny initial changes would propagate and amplify, eventually creating a completely different pattern than would have existed without the walker's presence. This is essentially what happens when 3I Atlas passes through our solar system. Its gravitational influence might nudge a distant comet by just a few meters, but over millions of years, that small change could determine whether the comet eventually falls toward the Sun, gets ejected from the solar system, or settles into a stable orbit. Multiply this effect by thousands of objects over dozens of passages, and you begin to see how interstellar visitors could significantly influence the architecture of our planetary system without any dramatic collisions or close encounters. The delivery of materials to Earth through this quiet influence might be one of the most important yet underappreciated aspects of interstellar visitation. As 3I Atlas warms during its passage through the inner solar system, it releases gas and dust that becomes part of the interplanetary medium. This material doesn't just disappear, it spreads throughout the solar system, creating a diffuse cloud that planets pass through as they orbit. Over time, Earth sweeps up this material, adding it to our planet's inventory of chemicals and potentially biological building blocks. The amount of material delivered this way during any single passage is tiny, perhaps only a few kilograms reaching Earth's surface over several years. But consider the cumulative effect over billions of years and potentially hundreds of passages. If 3I Atlas and similar objects have been regularly visiting our solar system since its formation, they could have delivered millions of tons of materials to Earth. This might seem like a lot, but spread over Earth's entire surface and mixed into its oceans and atmosphere, it represents a subtle but potentially significant contribution to our planet's chemical evolution. As you lie there in the quietness of night, perhaps you can imagine these invisible rivers of cosmic material flowing through our solar system, carrying molecules that might have formed around distant stars billions of years ago. Some of these molecules might be simple, just water or carbon dioxide, but others could be complex organics, the kinds of molecules that serve as building blocks for life. The quiet delivery of these materials wouldn't create dramatic changes, but would instead provide a steady supply of raw materials for chemical evolution, potentially influencing the development of a life on Earth in subtle but important ways. The influence of 3I Atlas on the asteroid belt represents another form of quiet influence that could have significant long-term effects. The asteroid belt exists in a delicate gravitational balance, with Jupiter's massive presence preventing the asteroids from coalescing into a planet, while also shepherding them into specific orbital regions. When an object like 3I Atlas passes through or near the asteroid belt, it introduces small perturbations that can shift this balance. Some asteroids might be nudged into slightly different orbits, changing their relationships with Jupiter's gravitational resonances. These orbital adjustments might seem insignificant, but they can have cascading effects over millions of years. An asteroid that moves into a different resonance with Jupiter might become unstable, eventually being ejected from the asteroid belt entirely. It could be sent toward the inner solar system, where it might deliver water and organic materials to terrestrial planets, or toward the outer solar system, where it might become a Trojan asteroid sharing Jupiter's orbit. Each of these outcomes represents a different future for that asteroid, and potentially for the planets it might eventually encounter. The Kuiper Belt and Oort cloud, those vast reservoirs of icy bodies in the outer reaches of our solar system, are particularly susceptible to the quiet influence of passing interstellar objects. These regions are so far from the Sun that orbital velocities are low and gravitational bonds are weak. A passing object like 3I Atlas, even at distances of billions of kilometers, could provide enough gravitational perturbation to alter the orbits of numerous comets. Some might be sent inward toward the Sun, becoming the spectacular comets we occasionally see in our skies. Others might be ejected entirely, becoming interstellar travelers themselves. This process of gravitational stirring in the outer solar system might be one of the primary mechanisms by which water and other volatiles are delivered to the inner planets. If interstellar visitors like 3I Atlas regularly perturb the Oort cloud, they could maintain a steady flow of comets toward the inner solar system, ensuring that planets like Earth receive periodic deliveries of water and organic materials. This cosmic delivery service might have been essential for maintaining Earth's oceans and atmosphere over geological time, compensating for losses due to atmospheric escape and chemical reactions. The quiet influence extends to the realm of cosmic dust as well. Our solar system is filled with microscopic particles, remnants of asteroid collisions and cometary activity. This dust slowly spirals toward the Sun due to the Poynting-Robertson effect, a consequence of absorbing and re-emitting solar radiation. As 3I Atlas passes through this dusty medium, its gravity creates density waves, regions where dust becomes slightly more or less concentrated. These density variations can affect the rate at which dust falls toward the inner planets, potentially creating periods of enhanced or reduced dust delivery to Earth. The biological implications of these variations in cosmic dust delivery are fascinating to contemplate. Cosmic dust carries not just minerals but also organic molecules, some of which might serve as nutrients for microorganisms in Earth's upper atmosphere or oceans. Variations in dust delivery could therefore influence biological productivity, potentially affecting everything from plankton blooms to atmospheric chemistry. While these effects would be subtle, they could accumulate over time to influence the evolution of Earth's biosphere. As you continue to relax, perhaps feeling yourself drifting like cosmic dust through space, consider how the quiet influence of objects like 3I Atlas might extend to Earth's climate system. The delivery of cosmic dust affects cloud formation, as dust particles serve as nucleation sites for water droplets and ice crystals. Changes in dust delivery could therefore influence cloud cover, precipitation patterns, and ultimately global climate. While these effects would be minor compared to other climate drivers, they could contribute to the complex tapestry of factors that determine Earth's climate over geological timescales. The quiet influence might also manifest through effects on the solar wind and Earth's magnetosphere. As 3I Atlas releases gas during its passage through the inner solar system, it creates a localized enhancement in the density of charged particles. When Earth passes through this enhanced region, our magnetosphere responds with subtle adjustments that could influence everything from auroral activity to the rate of atmospheric loss. These effects would be temporary and minor, but repeated passages over millions of years could have cumulative impacts on Earth's atmospheric evolution. There's something deeply philosophical about these quiet influences, these subtle connections between Earth and passing cosmic visitors. They remind us that causality in complex systems doesn't always manifest as dramatic events, but often works through the patient accumulation of small effects, like the proverbial butterfly whose wing beats eventually cause a hurricane. The gravitational whisper of 3i Atlas might set in motion chains of events that won't fully manifest for millions of years. The concept of quiet influence also challenges our tendency to think in terms of discrete events rather than continuous processes. We're drawn to dramatic moments like asteroid impacts or close encounters with comets, but the real story of our solar system's evolution might lie in the countless small interactions that occur between such events. Objects like 3i Atlas contribute to this background of continuous change, adding their small voices to the cosmic chorus that shapes planetary systems over billions of years. Consider how this quiet influence might have affected the development of Earth's moon system. The moon plays a crucial role in stabilizing Earth's rotation and creating tides that might have been important for the origin of life. But the moon's orbit isn't static. It's slowly spiraling away from Earth due to tidal interactions. The rate of this spiral could be influenced by the accumulation of cosmic materials delivered by passing objects like 3i Atlas. While the effect would be tiny, over billions of years it could influence the moon's orbital evolution and therefore its effects on Earth. The delivery of specific elements through quiet influence could have profound implications for Earth's geology and biology. For instance, many important biological processes require trace elements that are rare in Earth's crust, but more common in certain types of asteroids and comets. If objects like 3i Atlas have been delivering these elements to Earth over billions of years, they might have played an essential role in making our planet habitable. The quiet rain of cosmic materials could have provided the chemical diversity necessary for complex life to evolve. As we observe 3i Atlas receding into the darkness, its influence on our solar system seemingly diminishing with distance, it's worth remembering that influence and distance aren't always correlated in simple ways. Through the phenomenon of orbital resonance, objects can influence each other across vast distances if their orbital periods are related by simple ratios. 3i Atlas might be establishing or reinforcing resonances that will continue to shape our solar system long after the object itself has disappeared into interstellar space. The quiet influence of interstellar visitors might also extend to the realm of planetary rings and small moons. The delicate structures of Saturn's rings, for instance, are maintained by complex gravitational interactions with the planet's moons. A passing object like 3i Atlas could introduce perturbations that propagate through the ring system, potentially triggering the formation of new structures or the dissolution of existing ones. While we haven't observed 3i Atlas passing close enough to the giant planets to have such effects during this visit, previous passages might have left their marks on these beautiful and dynamic systems. Think about the patience required to study these quiet influences. Scientists must carefully track tiny changes in orbital parameters, analyze subtle variations in chemical compositions, and model complex gravitational interactions over millions of years. It's work that requires not just technical skill, but also imagination and persistence, the ability to see patterns in noise and connections across vast scales of space and time. In many ways, studying quiet influence is like listening for whispers in a hurricane, requiring us to filter out the obvious and dramatic to hear the subtle and profound. The concept of quiet influence also has implications for our search for life elsewhere in the universe. If interstellar objects regularly deliver organic materials and potentially even microorganisms between star systems, then life might spread through the galaxy, not through dramatic panspermia events, but through a quiet, continuous process of material exchange. Each planetary system might be constantly receiving and sending biological materials, creating a galactic ecosystem connected by these cosmic threads. As the night deepens, and you perhaps feel yourself approaching the edge of sleep, consider how you yourself are both a product and an agent of quiet influence. The materials that make up your body have been quietly accumulating on Earth for billions of years, some delivered by cosmic visitors like 3i Atlas. And your own existence, through the carbon dioxide you exhale and the heat you generate, creates tiny influences that ripple outward through Earth's systems. You are part of the quiet influence that shapes our planet, just as our planet is shaped by quiet influences from across the cosmos. The legacy of 3i Atlas's quiet influence will continue long after our observations of it end. The perturbations it has introduced to our solar system will propagate forward through time, influencing events that won't occur for millions of years. Some distant future comet might fall toward the Sun because of a tiny nudge 3i Atlas provided. Some asteroid might deliver water to Mars or one of Jupiter's moons because its orbit was slightly altered during this passage. These events will seem random and unconnected to future observers, but they'll actually be the delayed consequences of this quiet visitor's influence. The study of quiet influence teaches us humility about our ability to predict and control complex systems. We can model the obvious effects of 3i Atlas's passage with reasonable accuracy, but the subtle, long-term consequences remain largely unknowable. This isn't a failure of science, but rather a recognition of the fundamental complexity of nature. Every interaction, no matter how small, contributes to an unfolding pattern that's beautiful in its intricacy and humbling in its unpredictability. The echoes of evolution ripple through deep time like waves in a cosmic ocean, each passage of an object like 3i Atlas potentially creating subtle disturbances that influence the trajectory of life on Earth in ways we're only beginning to imagine. Life on our planet has experienced remarkable periods of explosive diversification, times when new forms seem to appear almost simultaneously, as if responding to some cosmic signal. The Cambrian explosion, the Great Ordovician biodiversification event, the rapid evolution of flowering plants, the sudden appearance of modern mammal groups, each of these evolutionary bursts remains partially mysterious, their timing and triggers not fully explained by conventional theories of gradual change. As you lie there in the darkness, perhaps feeling the slow rhythm of your own breathing, consider that this breath, this moment of consciousness, might be connected to ancient cosmic events, to visits from interstellar travelers that occurred when Earth was young and life was just beginning to explore the possibilities of complexity. The theory of panspermia, once dismissed as too speculative, has gained credibility as we've discovered the remarkable resilience of certain microorganisms and the ubiquity of organic molecules in space. Objects like 3i Atlas, we now understand, could serve as cosmic arcs, carrying the seeds of life or the molecular tools for evolution across the vast distances between stars. The surface of 3i Atlas, exposed to the harsh radiation of interstellar space for millions of years, might seem an unlikely refuge for biological materials. Yet we've learned that the interior of such objects could provide surprisingly protective environments. Beneath the processed outer layers, shielded from cosmic rays and maintaining extremely low temperatures that preserve complex molecules like insects in amber, there could exist pristine materials that have remained unchanged since the object's formation. If these materials include organic compounds or even dormant microorganisms, each passage through a planetary system becomes an opportunity for biological exchange. Consider the remarkable coincidences in the timing of certain evolutionary events and the calculated passages of objects on orbits similar to 3i Atlas. The emergence of photosynthesis, that revolutionary process that transformed Earth's atmosphere and enabled complex life, occurred during a period when our solar system was likely experiencing enhanced rates of interstellar visitation. The development of eukaryotic cells, with their complex internal structures and ability to process energy efficiently, happened during another such period. While correlation doesn't prove causation, the patterns are intriguing enough to warrant serious investigation. The mechanism by which passing objects like 3i Atlas might influence evolution extends beyond the simple delivery of biological materials. These visitors could trigger evolutionary changes through more subtle pathways, creating environmental pressures that drive adaptation and innovation. For instance, If the gravitational perturbations from passing interstellar objects periodically increase the rate of asteroid impacts on Earth, they could create cycles of destruction and opportunity, clearing ecological niches for new forms of life to emerge and diversify. Think about the role that cosmic dust, potentially delivered or disturbed by objects like 3I Atlas, might play in evolution. This dust doesn't just carry minerals, it carries information in the form of complex organic molecules, some of which might serve as templates or catalysts for biological processes. When this dust settles into Earth's oceans or onto land surfaces, it becomes part of the chemical environment in which life evolves. Variations in the delivery rate or composition of this cosmic material could influence everything from the availability of nutrients to the types of chemical reactions possible in living systems. The deep ocean trenches where some of Earth's most unusual life forms exist might be particularly influenced by materials delivered from space. These environments, isolated from sunlight and surface chemistry, depend on chemical energy sources that could be supplemented by cosmic deliveries. If objects like 3I Atlas have been providing steady inputs of certain chemicals over geological time, they might have enabled the evolution of unique metabolic pathways that wouldn't have been possible with Earth's native chemistry alone. The bizarre creatures living around deep-sea thermal vents, with their unusual biochemistries, might owe some of their revolutionary innovations to cosmic influences. As we examine the genetic code itself, that universal language shared by all life on Earth, we find tantalizing hints of possible cosmic connections. The specific amino acids used by Earth life, the particular arrangement of the genetic code, the chirality or handedness of biological molecules, all of these features might have been influenced by the materials available during life's origin and early evolution. If some of these materials arrive from space, delivered by ancient passages of objects like 3I Atlas, then the very nature of Earth life might bear the imprint of interstellar chemistry. The concept of evolutionary echoes suggests that the effects of cosmic visitors might reverberate through biological systems long after the initial influence. A small change in the availability of a particular element or molecule billions of years ago could have set evolution on a slightly different path, leading to the specific forms of life we see today. Like a composer whose early exposure to a particular melody influences all their later work, life on Earth might carry within its biochemistry and morphology the echoes of ancient cosmic encounters. Consider the mysterious periods of rapid evolution that punctuate Earth's history. The Avalon explosion, 575 million years ago, saw the sudden appearance of the Ediacaran fauna, Earth's first complex multicellular organisms. The Cambrian explosion 540 million years ago produced most of the major animal body plans that exist today. The Triassic explosion following the Permian extinction gave rise to the dinosaurs and many modern groups. Each of these events occurred relatively quickly in geological terms, as if life was responding to some external trigger or opportunity. Could some of these evolutionary accelerations have been triggered by the passage of objects like 3I Atlas? The delivery of new genetic material, either in the form of actual microorganisms or complex organic molecules that could be incorporated into existing life, might provide the raw material for evolutionary innovation. Alternatively, the environmental changes caused by cosmic influences, variations in climate, changes in atmospheric chemistry, or shifts in nutrient availability could create selective pressures that drive rapid evolution. The role of viruses in evolution provides another potential pathway for cosmic influence. Viruses are essentially packets of genetic information that can transfer genes between organisms, driving evolutionary change through horizontal gene transfer. If viable viruses or virus-like particles could survive interstellar journeys protected within objects like 3I Atlas, they could introduce entirely new genetic capabilities to Earth's biosphere. This wouldn't require the survival of complete organisms, just the preservation of genetic material that could be activated upon encountering suitable host cells. As you drift deeper into contemplation, perhaps beginning to feel, the boundaries between wakefulness and sleep becoming fluid, think about how your own existence represents a culmination of billions of years of evolutionary history, potentially influenced by countless cosmic encounters. Every cell in your body carries genetic information that has been shaped by the environment in which your ancestors evolved, an environment that included inputs from space. The calcium that strengthens your bones, the iron that carries oxygen in your blood, the trace elements that enable your neurons to fire. Some of these might have arrived on Earth courtesy of interstellar visitors. The timing of mass extinctions, those dramatic prunings of life's tree that create opportunities for new evolutionary directions, shows interesting correlations with periods when interstellar visitation rates might have been elevated. While most mass extinctions have been linked to specific causes like volcanic eruptions or asteroid impacts, the ultimate triggers for some of these events remain unclear. Could the gravitational influence of passing objects like 3I Atlas have destabilized asteroids that later impacted Earth? Could they have disturbed comet clouds, sending waves of impacts that stressed ecosystems to the breaking point? The recovery periods following mass extinctions are particularly interesting from an evolutionary perspective. These are times when life experiments with new forms, when previously marginal groups suddenly diversify to fill empty ecological niches. If objects like 3 Atlas delivered new biological materials or created new environmental conditions during these recovery periods, they could have profoundly influenced the direction of evolution. The mammals that inherited the Earth after the dinosaurs' extinction, for instance, might have evolved differently if cosmic influences had delivered different chemical or biological inputs during their early diversification. The evolution of intelligence itself might have been influenced by cosmic factors. The development of large brains requires significant amounts of certain trace elements and depends on environmental conditions that promote the survival of slowly developing vulnerable offspring. If the delivery of essential nutrients or the creation of stable environmental conditions was influenced by the passages of interstellar objects, then the emergence of intelligence on Earth might be partly a cosmic phenomenon. We might owe our ability to contemplate the universe to the universe's influence on our evolutionary history. Consider the remarkable convergent evolution seen in Earth's history, where unrelated organisms independently evolve similar solutions to environmental challenges. Eyes have evolved independently dozens of times. Flight has emerged in insects, pterosaurs, birds, and bats, and intelligence has developed to varying degrees in octopi, dolphins, elephants, and primates. This convergence suggests that evolution follows certain preferred pathways, possibly influenced by the fundamental chemistry and physics of life. If that chemistry has been shaped by cosmic inputs, then the patterns we see in evolution might reflect universal principles that operate throughout the galaxy. The role of cosmic radiation in causing genetic mutations provides another link between astronomical events and evolution. While most of Earth's surface is protected from cosmic rays by our atmosphere and magnetic field, the background rate of cosmic radiation still causes a significant number of mutations. During periods when Earth's magnetic field weakens, or when the solar system passes through regions of enhanced cosmic ray density, mutation rates could increase, potentially accelerating evolution. The passages of objects like 3I Atlas might correlate with some of these periods, adding another layer to their evolutionary influence. The symbiotic relationships that have been crucial to evolution on Earth might also have cosmic connections. The mitochondria that power our cells were once free-living bacteria that entered into symbiosis with early eukaryotic cells. The chloroplasts that enable photosynthesis in plants have a similar origin. If cosmic deliveries influence the availability or diversity of microorganisms during critical periods in Earth's history, they might have affected which symbiotic relationships formed and succeeded. The very nature of complex life on Earth might thus be traced back to cosmic influences. As the night continues, and you perhaps feel yourself floating in that peaceful space between waking and sleeping, consider how the story of evolution is really a story of connection and response, of life adapting to and incorporating influences from its entire environment, including the cosmic environment. The passages of objects like Three-Eye Atlas might be like verses in an epic poem, each one adding new themes and variations to the ongoing composition of life on Earth. We are living expressions of this cosmic poetry, our bodies and minds shaped by influences that stretch across space and time. The evolution of Earth's atmosphere, that thin envelope of gases that makes our planet habitable, has been profoundly influenced by life, but it might also bear the imprint of cosmic visitors. The Great Oxidation Event 2.4 billion years ago, when photosynthetic organisms first filled the atmosphere with oxygen, fundamentally changed the trajectory of evolution. But what triggered the emergence of photosynthesis in the first place? Could the delivery of specific minerals or organic molecules from space have provided the chemical precursors necessary for this revolutionary metabolic innovation? The coevolution of life and Earth's geology provides another avenue for cosmic influence on evolution. Life doesn't just adapt to its environment, it actively modifies it, creating new minerals, altering ocean chemistry, and even influencing plate tectonics through the weight of sediments and the lubrication of subduction zones. If cosmic visitors have influenced the availability of certain elements or the rate of certain geological processes, they've indirectly influenced the stage on which evolution plays out. The feedback loops between life, geology, and cosmic inputs create a complex system where small influences can have large evolutionary consequences. The distribution of life across Earth's various environments might also reflect cosmic influences. Why did certain groups evolve in particular locations? Why do some ecosystems support greater diversity than others? While local factors like climate and geography play major roles, the historical delivery of materials from space might have created chemical or biological gradients that influenced where and how different forms of life evolved. The hotspots of biodiversity we see today might be echoes of ancient cosmic deliveries, places where the right materials arrived at the right time to spark evolutionary innovation. Think about the role that rare elements play in evolution. Many enzymes require specific metal ions to function, and the availability of these elements can limit biological processes. Molybdenum, for instance, is essential for nitrogen fixation, the process that makes atmospheric nitrogen available to life. Selenium is crucial for certain proteins. Cobalt is needed for vitamin B12. If the terrestrial availability of these elements has been supplemented by cosmic deliveries, then the biochemistry of Earth life might be more cosmopolitan than we realize, incorporating materials and possibilities from across the galaxy. The evolution of photosynthesis itself might tell a cosmic story. The specific wavelengths of light that plants use for photosynthesis, the particular chlorophyll molecules they employ, the efficiency of the process, all of these features might have been influenced by the materials available when photosynthesis evolved. If some of those materials arrive from space, then the green color of Earth's vegetation might be a cosmic signature, a sign of the interstellar ingredients that went into life's recipe for capturing sunlight. The mysterious Ediacaran fauna, those enigmatic organisms that appeared before the Cambrian explosion and then largely vanished, might represent an evolutionary experiment influenced by cosmic factors. These creatures, with their fractal body plans and unclear relationships to modern life, appeared during a time when Earth was experiencing significant environmental changes. Could the passage of an object like Three-Eye Atlas have delivered materials or created conditions that enabled this unique evolutionary experiment? And could their disappearance be related to the end of those special conditions? The evolution of shells and hard parts during the Cambrian explosion might have been triggered by changes in ocean chemistry, influenced by cosmic deliveries. The sudden appearance of organisms with calcium carbonate shells required not just the evolution of shell-building machinery, but also the availability of sufficient calcium and carbonate in the oceans. If cosmic visitors influenced the delivery or cycling of these materials, they might have played a role in one of the most significant innovations in the history of life. As you continue to relax, perhaps feeling your consciousness beginning to drift like an interstellar object through the space of sleep, consider how the evolution of consciousness itself might be the universe becoming aware of itself through the emergence of life. If objects like 3i Atlas have influenced that evolution, then they're part of the process by which the cosmos develops the ability to observe and understand itself. We are the universe's evolved capacity for self-reflection, possibly shaped by the very cosmic forces we're now beginning to comprehend. The evolution of life's complexity shows interesting patterns that might reflect cosmic influences. There have been several major transitions in evolution, from simple cells to complex cells, from single cells to multicellular organisms, from individuals to colonies, from simple nervous systems to complex brains. Each of these transitions required new levels of organization and information processing. If cosmic deliveries provided crucial materials or created environmental pressures at key moments, they might have influenced when and how these transitions occurred. The role of mass extinctions in evolution cannot be overstated. These events, while devastating in the short term, have repeatedly redirected evolution, allowing previously marginal groups to diversify and dominate. The extinction of the dinosaurs allowed mammals to flourish. The Permian extinction set the stage for the age of reptiles. Earlier extinctions shaped the evolution of complex multicellular life. If some of these extinctions were influenced by cosmic factors, including the gravitational effects of passing objects like 3i Atlas, then the specific trajectory of evolution on Earth has been shaped by our planet's interactions with interstellar visitors. The evolution of flight, one of life's most remarkable innovations, might have cosmic connections we haven't considered. Flight has evolved independently multiple times, suggesting it's a natural solution to certain environmental challenges. But the specific timing of when flight evolved in different groups might have been influenced by factors including atmospheric density, oxygen levels, and the availability of certain materials for building lightweight yet strong structures. If cosmic influences affected any of these factors, they might have influenced when and how life took to the skies. The development of bioluminescence, the ability of organisms to produce light, provides another example of an evolutionary innovation that might have cosmic connections. Bioluminescence requires specific chemical reactions involving luciferin and luciferase, molecules that might have been rare or absent on early Earth. If the building blocks for these molecules arrived from space, or if cosmic deliveries influenced their availability, then the beautiful light displays we see in fireflies, deep-sea creatures, and certain fungi might be gifts from the stars. The evolution of extremophils, organisms that thrive in conditions that would kill most life, might have been influenced by materials or genetic information delivered from space. These organisms, found in boiling hot springs, acid lakes, deep underground, and other harsh environments, often have unique biochemistries that allow them to survive where others cannot. If some of their metabolic innovations came from cosmic sources, it would explain how life managed to colonize such challenging environments and might give us insights into what life could be like on other worlds. As the night deepens and you drift further into contemplation, think about how the story of evolution is really many stories woven together. Stories of competition and cooperation, of innovation and extinction, of Earth and cosmos. The passages of objects like 3i Atlas add cosmic threads to this tapestry, connecting Earth's biological history to the wider universe in ways both subtle and profound. Every organism that has ever lived, including you, is part of this grand narrative, shaped by influences that stretch from the molecular to the galactic scale. The evolution of symbiosis, one of the most important drivers of biological complexity, might have been influenced by the mixing of different microbial communities brought together by cosmic events. When materials from space deliver new microorganisms or create environmental disruptions that force different communities together, they create opportunities for new symbiotic relationships to form. The the lichens that carpet rocks, the corals that build reefs, the bacteria in our guts that help us digest food, all represent symbiotic relationships that might have been influenced by cosmic factors. The timing of evolutionary innovations often seems to follow patterns that are hard to explain through purely terrestrial factors. Why did flowering plants suddenly diversify in the Cretaceous? Why did mammals develop complex social behaviors when they did? Why did certain groups of organisms experience rapid speciation, while others remained stable for hundreds of millions of years? While many factors certainly contributed to these patterns, the influence of cosmic visitors like 3i Atlas might be one piece of the puzzle we've been missing. The evolution of Earth's ecosystems, those complex webs of interaction between organisms and their environment, has created a biosphere of remarkable resilience and beauty. But this biosphere hasn't developed in isolation. It has been shaped by inputs from space, including materials delivered by interstellar visitors, cosmic radiation, and the gravitational influences of passing objects. The Amazon rainforest, the coral reefs, the vast microbial communities in soil and ocean, all might bear the subtle imprint of cosmic influences accumulated over billions of years. The concept of evolutionary echoes reminds us that we're not just products of Earth, but children of the cosmos, assembled from materials that have travelled between stars and shaped by influences that connect us to the galaxy at large. As you lie there, perhaps beginning to dream, you're experiencing consciousness that might itself be an echo of cosmic influences, a capacity for awareness that emerged from the interplay between terrestrial evolution and celestial visitation. In contemplating objects like 3i Atlas, we're not just studying distant cosmic phenomena, but exploring the deep history of our own existence. The greatest symphony of cosmic connections plays out on scales that dwarf human comprehension. Yet we are integral notes in this vast composition, our existence both dependent on and contributing to patterns that span galaxies and eons. 3 Atlas is not alone in its journey through the cosmos. It's part of an immense population of wandering objects, each following its own path through space and time, yet collectively creating flows and patterns that connect star systems across unimaginable distances. Current estimates suggest that our galaxy might contain septillions of such objects, more interstellar wanderers than there are grains of sand on all of Earth's beaches, each one a potential messenger between worlds, a possible carrier of materials and perhaps even life itself. As you drift deeper into the peaceful space between waking and sleeping, imagine yourself rising above Earth, above the solar system, above the local neighborhood of stars, until you can see the great spiral arms of our galaxy, that magnificent pinwheel of stars slowly rotating in the darkness. Within this cosmic cityscape, invisible highways of gravitational influence connect the stars, channels through which objects like 3i Atlas flow like cells through celestial bloodstreams. These paths aren't random, but follow the subtle geography of space-time, shaped by the combined gravity of billions of stars and the dark matter that forms the hidden skeleton of our galaxy. The discovery that 3i Atlas might be part of a loose stream of objects suggests that these cosmic highways carry not individual travelers, but entire caravans, groups of objects that were ejected from the same star system, or formed in the same region of space billions of years ago. Like migrating birds that follow ancient routes across continents, these objects follow paths worn smooth by gravity through the vastness of interstellar space. Some of these streams might be the remnants of planetary systems that were disrupted by stellar encounters or supernovae, their materials scattered across the galaxy like seeds from a cosmic dandelion. Consider the profound implications of this interconnected galaxy. Every star system, including our own, is constantly losing and gaining material through these cosmic exchanges. When Jupiter deflects a comet out of our solar system, that comet becomes an interstellar traveler that might one day visit another star. When 3i Atlas passes through our neighborhood, it represents a return of materials that were sent out by some distant star system, perhaps billions of years ago. We're all part of a galactic economy of matter and energy, a vast recycling system that ensures no star system remains isolated for long. The mathematics of this cosmic symphony are beautiful in their complexity. Each object follows the laws of gravity with perfect precision, yet the combined movements of trillions of objects create patterns that are chaotic in the technical sense, deterministic but unpredictable beyond certain time horizons. This means that, while we can calculate the general flows and patterns of interstellar objects, we can never predict exactly which specific object will visit which star system at what time. The galaxy is like a vast musical instrument, where every string affects every other string, creating harmonies and dissonances that evolve over cosmic time. Think about what this means for the distribution of life in the galaxy, if indeed life exists elsewhere. If objects like 3i Atlas can carry organic materials or even microorganisms between star systems, then life might not arise independently on each habitable world. Instead, it might spread through the galaxy in waves, carried by these interstellar messengers. A single genesis of life, perhaps billions of years ago in some long-dead star system, might have seeded thousands or millions of worlds through this process of interstellar panspermia. Earth might not be an isolated garden of life, but part of a vast galactic ecosystem, connected to other living worlds by these travelling seeds. The variety of objects in this interstellar population is staggering to contemplate. While 3i Atlas appears to be a relatively typical comet, composed of ice and rock with organic molecules mixed in, other interstellar visitors might be very different. Some might be metallic asteroids, remnants of planetary cores destroyed in ancient collisions. Others might be exotic objects we haven't even imagined. Perhaps fragments of carbon planets, where diamond is as common as rock, or pieces of worlds that formed around stars very different from our Sun. Each type of object would carry different materials, different possibilities for the worlds they visit. The distribution of these objects through space isn't uniform but follows patterns determined by the galaxy's structure and history. Regions where stars are forming might be rich in certain types of interstellar objects, ejected from young planetary systems still finding their equilibrium. Ancient regions might be dominated by objects that have been travelling for billions of years, processed by cosmic radiation and countless stellar encounters. The solar system's journey through different regions of the galaxy means we encounter different populations of interstellar visitors at different times, each bringing their own unique contributions to our cosmic neighbourhood. As you lie there in the darkness, perhaps you can imagine these vast rivers of objects flowing through space, invisible to our eyes but revealed by careful observation and calculation. They move with patient inevitability, taking millions of years to travel between stars yet never stopping, never resting. Some have been journeying since before our Sun was born, carrying within them materials from the galaxy's youth. Others are recent ejections, still bearing fresh materials from active planetary systems. Together, they form a kind of circulatory system for the galaxy, distributing materials and potentially life itself across cosmic distances. The detection of Oumuamua in 2017 and Borisov in 2019, followed by 3i Atlas and other candidates, has revealed that we're living in a special moment in human history. We've developed the technology to detect these cosmic visitors just as our understanding of planetary formation and galactic evolution has reached a point where we can appreciate their significance. It's as if we've suddenly developed a new sense, allowing us to perceive connections and patterns that were always there but previously invisible to us. We're like children who have just learned to read, suddenly realizing that the marks on pages are actually messages, stories, entire worlds of meaning. The implications for our understanding of our place in the universe are profound. We're not isolated on a single world, cut off from the rest of the cosmos by unbridgeable distances. Instead, we're part of a galactic community, connected to other star systems by these travelling ambassadors. Every piece of cosmic dust that falls to Earth, every meteorite we collect, potentially carries information about distant parts of our galaxy. We're constantly receiving messages from the cosmos, written in the language of chemistry and isotope ratios, waiting for us to decode them. The search for signs of technology or artificial modification in interstellar objects has so far found nothing definitive, but the possibility remains tantalizing. If intelligent civilizations exist elsewhere in the galaxy, they might use interstellar objects as a means of communication or exploration. An advanced civilization could potentially modify the orbits of objects like 3I Atlas to direct them towards specific star systems, or even engineer artificial objects designed to look natural while carrying hidden messages or technology. While 3I Atlas shows no signs of artificial origin, the fact that we're now capable of detecting and studying such objects means we could potentially identify artificial visitors if they exist. The Greater Symphony also includes the gravitational waves that ripple through space-time when massive objects accelerate, the electromagnetic radiation that carries information at the speed of light, and the slow drift of stars themselves as they orbit the galactic center. All of these phenomena are interconnected, each influencing the others in subtle ways. The passage of 3E Atlas through our solar system creates tiny gravitational waves, too small for our current detectors, but nonetheless real, spreading out through space to eventually reach distant stars. In this way, every event in the cosmos is connected to every other event, creating a symphony of infinite complexity and beauty. Consider the role that dark matter might play in this cosmic symphony, this mysterious substance, which makes up most of the matter in the galaxy but doesn't interact with light, creates gravitational channels and wells that influence the motion of visible matter. Objects like 3I Atlas move through a landscape shaped by dark matter, following paths influenced by invisible masses we can only detect through their gravitational effects. The interstellar highways we mentioned earlier are partly defined by the distribution of dark matter, creating preferred routes through space that interstellar objects tend to follow. The future of our understanding of this greater symphony lies in ambitious projects to directly study interstellar objects. Scientists have proposed missions that would wait in Earth's orbit, or at gravitational balance points, ready to intercept and study the next interstellar visitor that comes close enough. These missions could potentially sample materials from other star systems directly, analyzing their composition in detail and looking for signs of biological activity or artificial modification. Imagine the excitement of receiving the first samples from an interstellar object, holding in our hands materials that formed around another star, possibly billions of years ago. The cultural and philosophical implications of understanding our place in this greater symphony are still unfolding. Every human culture has stories about the stars, myths that try to explain our relationship to the cosmos. Now we're discovering that these stories were more right than their creators knew. We really are connected to the stars, not through mystical forces, but through the patient exchange of materials over cosmic time. The atoms in our bodies, the water we drink, the air we breathe, all have been influenced by this cosmic symphony. We are not separate from the universe, but woven into its very fabric. As the night continues and you perhaps feel yourself beginning to drift toward dreams, think about how the passage of 3I Atlas connects us to every other star system it has visited or will visit. Through this single object, we're linked to potentially dozens of other stars, each with their own planets, their own possibilities for life. If conscious beings exist in any of those systems, they might have observed 3I Atlas just as we have, wondered about its origin just as we do. In this way, 3 Atlas becomes a kind of cosmic connection, a shared experience that links intelligent beings across the galaxy. The distribution of elements in the galaxy, what astronomers call metallicity, varies from region to region based on the history of star formation and supernova. Objects like 3I Atlas carry samples of these different regions, mixing materials from various parts of the galaxy. This cosmic stirring helps homogenize the galaxy's chemistry over billions of years, ensuring that the building blocks of planets and potentially life are distributed widely. Without this mixing, some regions might be too poor in heavy elements to form rocky planets or support complex chemistry. The greater symphony thus includes not just the movement of objects, but the gradual blending of the galaxy's ingredients. The possibility that our solar system might be special in some way, perhaps unusually stable, or located in a particularly favourable region of the galaxy, has to be reconsidered in light of our growing understanding of interstellar visitors. If materials and potentially life itself can travel between star systems, then the conditions necessary for life don't need to arise independently in each system. Instead, favourable conditions in one system could benefit many systems through the process of interstellar exchange. Earth's biodiversity might not be solely the product of local conditions, but might reflect contributions from across the galaxy. Think about the patience and vision required to study phenomena that unfold over such vast timescales. Scientists studying objects like 3i Atlas know they're contributing to a body of knowledge that won't be complete for generations, perhaps centuries. They're like medieval cathedral builders working on projects they'll never see finished. Yet they persist. Driven by curiosity and the knowledge that understanding our place in the cosmic symphony is one of humanity's greatest undertakings. Each observation, each calculation, each theory adds another note to our growing comprehension of the universe. The technology we're developing to study interstellar objects will have implications beyond astronomy. Learning to track and potentially intercept fast-moving objects from deep space requires advances in propulsion, navigation, and robotics that could benefit space exploration more broadly. The same capabilities that would allow us to study an object like 3i Atlas up close could enable us to deflect potentially hazardous asteroids, mine resources from space, or send our own probes to other star systems. In this way, our efforts to understand the greater symphony are also preparing us to become active participants in it. The role of artificial intelligence and machine learning in detecting and studying interstellar objects is becoming increasingly important. The amount of data generated by modern telescopes is so vast that human astronomers couldn't possibly examine it all. Instead, AI systems scan the data, looking for the subtle signatures of moving objects, flagging interesting candidates for human review. As these systems become more sophisticated, they might begin to identify patterns and connections that human scientists have missed, revealing new aspects of the cosmic symphony that we hadn't imagined. As you continue to relax, perhaps feeling your thoughts becoming more fluid and dreamlike, consider how the story of 3i Atlas and the greater symphony it's part of changes our perspective on time. Human lives are brief flashes compared to the journeys of interstellar objects, yet we've developed the ability to comprehend and study phenomena that unfold over billions of years. We can look at 3i Atlas and see not just a chunk of ice and rock, but a traveller with a history stretching back to the galaxy's youth, and a future that will continue long after our sun has died. This ability to transcend our temporal limitations through understanding is one of consciousness's most remarkable achievements. The distribution of water in the galaxy, essential for life as we know it, might be largely controlled by the movement of objects like 3i Atlas. Water is common in the outer regions of planetary systems where it can freeze into ice, but getting that water to inner rocky planets where it can exist as liquid is challenging. Interstellar objects, particularly comets like 3i Atlas, could be the primary delivery mechanism, carrying water from the cold outer regions of one star system to the warm inner regions of another. The oceans of countless worlds might owe their existence to this cosmic water delivery service. The greater symphony includes not just physical objects but also information, patterns of organization that can influence the development of planetary systems and potentially life. When an object like 3i Atlas passes through our solar system, it doesn't just bring materials, it brings information about conditions in other parts of the galaxy. The isotope ratios in its ice tell us about the nuclear processes in distant stars. The organic molecules on its surface reveal what kinds of chemistry are possible in other environments. Even its orbit carries information, telling us about the gravitational landscape it has traversed. The possibility that the galaxy might have regions that are particularly favourable for the development of life, galactic habitable zones, adds another dimension to the greater symphony. If such zones exist, the movement of objects like 3I Atlas between them could be crucial for spreading life throughout the galaxy. Objects ejected from habitable systems would preferentially carry materials conducive to life, and their delivery to other potentially habitable systems could jumpstart biological evolution. In this view, the galaxy isn't just passively hospitable to life, but actively promotes its spread through these cosmic connections. As the boundaries between waking and sleeping continue to soften, let your mind drift with the cosmic flows we've been exploring. You are part of this greater symphony, made from materials that have travelled between stars, shaped by processes that connect you to the entire galaxy. Every atom in your body has a cosmic history, a story of stellar birth and death, of patient journeys through interstellar space, of chance encounters and gradual accumulation. You are a temporary arrangement of ancient materials, a brief note in an eternal symphony, yet capable of perceiving and appreciating the magnificent composition of which you're part. The study of objects like 3I Atlas is teaching us that the galaxy is more alive with movement and exchange than we ever imagined. It's not a collection of isolated star systems, but a dynamic, interconnected ecosystem where materials, energy, and possibly life itself flow in complex patterns. We're beginning to see the galaxy not as a vast emptiness punctuated by islands of matter, but as a living system with its own cycles, rhythms, and processes of evolution. Understanding our place in this system is perhaps the greatest adventure our species has undertaken, a journey of discovery that has only just begun. Forever questions linger in the cosmic darkness, like stars that will never fade. Each answer we discover about objects like 3 Atlas opening doorways to mysteries even more profound. As this cosmic wanderer continues its eternal journey away from our sun, growing fainter in our telescopes until it disappears entirely from our ability to detect it, we're left with questions that might never be fully answered, and perhaps that's the most beautiful truth of all. Will 3 Atlas return to our solar system in 10 million years, 100 million, or will gravitational encounters during its journey alter its path forever, sending it to unexplored regions of the galaxy, where other worlds and other observers might wonder at its passing just as we have? The calculations suggest many possibilities, each one a different future written in the mathematics of orbital mechanics. But the uncertainties grow with each passing millennium until prediction becomes mere speculation. Perhaps that's fitting, for the universe seems to delight in preserving its mysteries even as it reveals its wonders. We stand at the shore of an infinite ocean of questions, having glimpsed just one wave in an endless sea of cosmic possibilities, and in that glimpse we've seen reflections of ourselves, our origins, and our potential futures written in ice and stone and starlight. Think about what it means that we can never know for certain whether 3I Atlas has visited us before or will visit us again. This uncertainty isn't a failure of our science, but rather a fundamental property of complex systems evolving over cosmic time. The three-body problem, that classical challenge of celestial mechanics, becomes infinitely more complex when we consider the gravitational influences of billions of stars, the invisible presence of dark matter, and the slow evolution of the galaxy itself. Each calculation we make is like trying to predict the exact shape of a cloud millions of years in the future. We can speak of probabilities and patterns, but the specific details remain forever beyond our reach. Yet within this uncertainty lies a profound beauty. If we could predict everything, if we could know with certainty every future position of every object in the cosmos, the universe would be a clockwork mechanism, deterministic and ultimately static. Instead, we find ourselves in a cosmos that preserves mystery at its heart, where quantum uncertainty at the smaller scales and chaotic dynamics at the larger scales ensure that there will always be surprises, always be new discoveries, always be questions to pursue. 3 Atlas embodies this beautiful uncertainty, a messenger from the unknown carrying questions rather than answers. As you drift deeper into the peaceful borderland between consciousness and sleep, consider how the questions raised by 3i Atlas connect to the deepest mysteries of existence. Is life unique to Earth? Or does it exist throughout the galaxy, perhaps spread by objects like this cosmic wanderer? Is consciousness an inevitable outcome of cosmic evolution? Or are we a rare accident in a universe mostly devoid of awareness? What forms might life take on worlds with different chemistry, different conditions, different histories of cosmic influence? These questions ripple outward from our observation of a single interstellar object, connecting to everything we wonder about our place in the universe. The mystery of 3i Atlas's composition continues to deepen with each observation. While we've identified water ice, various organic molecules and familiar minerals, there are spectral signatures that don't quite match anything in our databases. These might be materials formed under conditions unlike anything in our solar system, perhaps ices compressed under pressures we can barely imagine, or minerals forged in the hearts of stars very different from our sun. Each unidentified signature is a question mark, a reminder that the universe contains possibilities we haven't yet imagined. Consider the philosophical implications of never being able to fully know an object like 3i Atlas. We can observe its surface, analyze its emissions, track its trajectory, but its interior remains hidden, its full history unknowable. It's like meeting a stranger in passing, exchanging a brief glance, and then watching them disappear into a crowd, knowing you'll never learn their story. This limitation of knowledge isn't just technical, but fundamental. There's simply no way to access information about where 3i Atlas formed, what star system it originally called home, or what cosmic events shaped its journey to us. The questions multiply when we consider the possibility that 3i Atlas might carry preserved materials from the early universe. If this object formed billions of years ago from the debris of first-generation stars, it might contain isotopes and minerals that no longer form in today's universe. It could be a time capsule from an era when the cosmos was younger, hotter, and chemically simpler. The organic molecules it carries might represent early experiments in cosmic chemistry, preserved in ice for eons like insects in amber. We might be looking at evidence of how the universe first learned to build the complex molecules that would eventually become the foundation of life. The role of time in our understanding of 3i Atlas raises profound questions about permanence and change. This object has potentially existed for billions of years, far longer than our species, our planet in its current form, or even our sun. Yet it too is temporary, slowly losing mass with each stellar passage, being reformed by cosmic radiation and micrometeorite impacts. Is it the same object it was 1 billion years ago? Will it still exist 1 billion years from now? These questions echo ancient philosophical puzzles about identity and persistence, played out on a cosmic scale. As you lie there in the darkness, perhaps feeling the gentle pull of approaching sleep, think about how the questions raised by 3i Atlas mirror the questions we ask about ourselves. Where did we come from? Where are we going? What is our purpose? Are we alone? Just as we wonder whether 3i Atlas has visited Earth before, we wonder whether consciousness has emerged before in the universe. Just as we speculate about the object's future trajectory, we ponder humanity's cosmic destiny. In studying this interstellar visitor, we're really studying ourselves, using the cosmos as a mirror to examine our own nature and possibilities. The question of whether objects like 3i Atlas could transport life between star systems remains one of the most tantalizing mysteries. We know that certain organisms can survive in space for extended periods. Tardigrades, certain bacteria, and fungal spores have all demonstrated remarkable resilience to vacuum, radiation, and extreme temperatures. If such organisms were embedded deep within an object like 3i Atlas, Protected from the worst of cosmic radiation, could they survive journeys lasting millions of years? And if they could, what would this mean for our understanding of life's distribution in the universe? The timing of 3I Atlas's visit raises its own questions. Why are we detecting interstellar objects now in the early 21st century? Is it simply because we've developed the technology to see them, or is there something special about this moment in cosmic time? Are we experiencing an unusual cluster of interstellar visitors, perhaps related to our solar system's current position in the galaxy? Or have these objects always been passing through, unnoticed by previous generations who lack the tools to detect them? Each possibility tells a different story about our relationship with the cosmos. The cultural and spiritual questions raised by 3I Atlas are as profound as the scientific ones. How does knowing that we're regularly visited by messengers from other star systems change our sense of identity as a species? Does it make Earth feel less special or more connected to the cosmic community? Different cultures and individuals will answer these questions differently, but the very fact that we're asking them represents a new chapter in human consciousness. We're the first generation to know with certainty that pieces of other solar systems regularly pass through our own, and this knowledge inevitably changes how we see ourselves. Think about the questions that future generations will ask about 3I Atlas, questions we can't even formulate because we lack the conceptual framework to imagine them. Just as ancient astronomers couldn't have asked about the object's spectral signatures or isotope ratios because they didn't know such things existed, we're surely blind to aspects of 3I Atlas that future scientists will consider obvious and essential. This humbling realization reminds us that our current understanding, however sophisticated it seems, is just one step in an endless journey of discovery. The question of how many objects like 3I Atlas pass through our solar system undetected haunts astronomers. Current estimates suggest we've only spotted a tiny fraction of interstellar visitors, perhaps less than 1% of those that come close enough to potentially detect. How many cosmic messengers have we missed? How many opportunities to study materials from other star systems have passed by while we weren't watching? And what might we learn if we could detect and study them all? These questions drive the development of new telescopes and detection systems, each advancement opening our eyes a little wider to the cosmic traffic flowing through our neighborhood. The mystery of 3I Atlas's rotation adds another layer of questions. The object tumbles through space in a complex pattern that suggests an irregular shape, possibly the result of collisions or uneven sublimation over billions of years. But what forces set it spinning in the first place? Was it ejected from its original star system in a violent event that sent it tumbling? Has its rotation been modified by close encounters with other stars? The way it spins might encode information about its history, but decoding that information requires understanding processes that occurred millions or billions of years ago in unknown locations. As the night deepens and your thoughts become increasingly dreamlike, consider how the questions surrounding 3I Atlas connect to the ultimate mystery of existence itself. Why is there something rather than nothing? Why does the universe have the particular laws and constants that allow for complex chemistry and life? Is our cosmos one of many, each with different properties and possibilities? These metaphysical questions might seem far removed from the study of a single interstellar object, but they're connected by the thread of cosmic wonder that runs through all scientific inquiry. The possibility that 3I Atlas might return to our solar system in the distant future raises questions about continuity and memory across cosmic time. If it does return millions of years from now, will there be anyone here to observe it? Will Earth still be habitable? Will humanity have evolved into something unrecognizable? Or will we have spread to other star systems, perhaps riding objects like 3I Atlas to new homes? The object might outlive our species, our planet, even our sun, carrying within its frozen interior the only remaining evidence that our solar system once existed. The questions multiply when we consider the network effects of interstellar objects. If 3i Atlas has influenced the orbits of asteroids in our solar system, and those asteroids have influenced others, creating cascading chains of gravitational interactions, where does 3i Atlas's influence end? Similarly, if it has delivered materials that became part of Earth and potentially part of the living organisms, are we in some sense still connected to it even as it travels away? These questions challenge our usual notions of causality and connection, suggesting that influences can persist and propagate in ways we're only beginning to understand. The search for patterns in the arrivals of interstellar objects raises statistical questions that push the limits of our mathematical tools. With only a handful of confirmed interstellar visitors, how can we determine whether their arrivals are random or follow some underlying pattern? Are there preferred directions from which these objects approach? Are there certain times when visits are more likely? These questions require us to develop new statistical methods for dealing with rare events and incomplete data, advancing mathematics as well as astronomy. As you hover on the edge of sleep, perhaps feeling your consciousness beginning to dissolve into dreams, reflect on how the questions raised by 3i Atlas will continue long after we've lost the ability to observe it. Future generations will inherit these mysteries, adding their own questions and perhaps finding some answers that elude us. But they too will face the horizon of the unknowable, the boundary beyond which questions multiply faster than answers can be found. This isn't a failure of science, but its greatest triumph, the recognition that the universe is inexhaustibly rich with mystery. The question of what 3i Atlas might teach us about our own future is particularly poignant. If this object was ejected from a planetary system that no longer exists, it serves as a reminder that all things are temporary, even solar systems. Our sun will eventually die, our planets will be scattered or consumed, and perhaps pieces of Earth will become interstellar travelers like 3i Atlas, carrying fragments of our world to distant stars. Will those fragments preserve any evidence of the life that once thrived here? Will some future civilization study them and wonder about us, just as we wonder about 3i Atlas's origins? The philosophical question of whether we can ever truly know anything about objects like 3i Atlas touches on fundamental issues in epistemology. All our knowledge comes through observation and inference, but observation is limited by our instruments and perspectives, while inference depends on assumptions that might be wrong. We assume the laws of physics are the same throughout the universe, but what if they vary in subtle ways? We assume 3i Atlas is a natural object, but what if it's artificial in ways we can't recognize? These questions remind us that all knowledge is provisional, subject to revision as we learn more. The beauty of forever questions lies not in their answers, but in what they reveal about the nature of inquiry itself. Each question about 3i Atlas opens onto other questions, creating an infinite regress of mystery that mirrors the infinite depth of the universe itself. We're finite beings trying to comprehend the infinite temporary arrangements of matter contemplating the eternal, and in that effort lies both profound humility and remarkable courage. We know we'll never have all the answers, yet we keep asking questions, keep searching, keep wondering. As 3i Atlas continues its journey into the darkness, it carries with it not just ice and rock, but also the fact of our observation. The reality that conscious beings on a small planet orbiting an ordinary star took notice of its passing and wondered about its nature. In some philosophical sense, we've become part of its story just as it has become part of ours. The questions we've asked about it, the theories we've proposed, the wonder it has inspired, all of this is now woven into the meaning of 3i Atlas, at least from our human perspective. Tonight, as you finally drift into sleep, you become like 3i Atlas itself, a traveler moving through spaces of consciousness, carrying within you the accumulated experiences of your journey, heading toward destinations unknown. Your dreams might take you anywhere, just as 3i Atlas's orbit might take it anywhere in the galaxy. And just as we can only speculate about where 3i Atlas will go next, You can't predict what dreams await you in the hours ahead. But that uncertainty isn't something to fear. It's the source of all possibility, all discovery, all wonder. The story of Thuris's Atlas reminds us that we live in a universe where questions matter more than answers, where mystery is more fundamental than knowledge, where wonder is the appropriate response to existence. We are made of stardust, shaped by cosmic forces, connected to every corner of the universe through threads of gravity and exchanges of matter and energy. We are temporary patterns in an eternal dance, brief notes in an infinite symphony, fleeting thoughts in a cosmic mind that might be thinking itself into existence through us. And so, as you surrender to sleep, remember that you are part of something infinitely larger and more wonderful than any individual can fully comprehend. The atoms in your body have travelled between stars. The thoughts in your mind connect you to the entire cosmos, and your capacity for wonder makes you a conscious participant in the universe's attempt to understand itself. Like Three-Eye Atlas, you're both a product of cosmic forces and an active agent in the ongoing story of the universe. You're a forever question, beautiful in your mystery, perfect in your incompleteness, eternal in your temporary form. Sleep now and dream of cosmic journeys, of ice and stone sailing through starlight, of connections that span galaxies and time itself. Dream of Three-Eye Atlas, continuing its endless voyage, carrying within it the seeds of worlds, the memories of stars, the possibilities of life. And know that when you wake, the universe will still be there, vast and mysterious and wonderful, waiting for you to ask new questions, to wonder at new mysteries, to add your voice to the cosmic symphony that has been playing since time began and will continue long after the last star fades into darkness. For in the end, we are all travellers like Three-Eye Atlas, passing briefly through the light, carrying our stories through the darkness, connected to everything that was and everything that will be through the eternal dance of matter and energy, space and time, question and wonder. We are the universe discovering itself, one observation at a time, one question at a time, one moment of conscious awareness at a time. And that, perhaps, is the most beautiful mystery of all, that the cosmos has evolved the capacity to contemplate itself through beings like us, temporary as we are, limited as we are, yet capable of infinite wonder at the magnificent mystery of existence.